What's up, everyone? Welcome to a very special episode of Fire is Fire. My name is Jameson Wellborn, and today I'm only joined by one of my co-hosts, Dr. Brian Paul. And the reason for that is the talented RJ Ellis is actually going to be joining the panel today. We somehow have been able to pull together an incredible cast of incredibly knowledgeable people into the room today to discuss one topic. And that topic is pigment in resin and its subsequent correlation to quality. And so, without further ado and no hype necessary, I'd like to bring in the whole panel and we'll get to know them and go through and do some intros one by one. So everybody jump on in. Thank you so much for taking the time. We've tried to put together a panel of individuals that are not only highly respected in their communities and schools of thought, but have a really interesting and differing opinions. So super excited to have you all here, man. Thank you so much for joining.
Oh, yeah.
So, because there's a lot of people, before we jump right into it, I want to do really quick intros. So if everybody could just take 1 to 2 minutes and tell us, where you're based and what your areas of specialization or focus have been on in the last 5 years, I think that would give everybody a point of reference so we can jump in and really dive deep into this convo. So starting just directly beside me, Adam, could you kick it off?
Yes, I'm in Northern California. My name's Adam Simpson. And simply Adam on Instagram, if you want to call me by my Instagram name, which it seems to be very common these days that we do that. But I love making hash. I like to originally was really into trying to make it dry, and because I was always making it wet. And so people kind of have known me as for maybe drying hash and then being able to have a hash that's not just going to turn brown instantly. And that kind of, I just got better and better at that. Still suck sometimes at that. It's not always, it's very hard still to this day. And that's why the freeze dryer is so cool, to help out with that and maybe lower the amount of time that I have to dry with my hands. But other than that, I love making rosin nowadays. I want to move on to the next person. I hope I answer you. What else are we talking about? Pigment?
Absolutely.
Hold on, was that a little bit of blasphemy? Adam just said he likes making rosin. You like smoking rosin too?
Yeah, so it's been a long time. I've been making rosin since it first came out, and trying to join the wave. But now I feel like I'm fully involved. I've been making it over the years. Usually my girlfriend makes it because she's really, really good at not doing blowouts. But now I actually did a little collab with HQ and Babushka Farms in Barcelona. It was 10 grams. We pressed it, no blowout, first try. So I'm getting better. I'm getting better at making rosin.
That's awesome. Who's up next time?
Next we got. We can have Rick. Hold on, I just have to post this.
Very true. Very true.
What's up, guys? My name's Rick Moriarty. I'm the CIO/COO of High North Laboratories. We're in Toronto, Canada. So I've been growing and making hash for about 23 years myself. And lately, like about 5-6 years ago, my partner John, he approached me with the idea of a cannabis lab, knowing that the industry kind of lacks that specialized cannabis only laboratory and people who actually are from the industry legacy. And so he started that. He brought me along. So I didn't found it. I got to join with him though, and he's my partner. And now we've got probably I think we did about 6,000 samples roughly in legacy, rating it. We came up with an algorithm to analytically rate it based on certain results, terpenes, comparative analysis. And then now in the legal market, we probably tested, I think we're just over 22,000 samples now. So we've tested and I've seen a ton of different kinds of cannabis products, from the absolute garbage to the fire that I'm sure everyone on this round table is all producing themselves. So yeah, that's where I'm at.
Awesome, man. Thanks so much. I appreciate you being here, Rick.
Thank you very much for the invite, by the way, guys. It's awesome.
Absolutely, man. Have a lab guy there. It's super valuable for this conversation, and so just appreciate you taking the time. Who's up
Absolutely.
next, Brad? It's hard for me to tell the order from here. Oh, you're muted, Alex. You just got to hit your mute button.
Hey everybody, Alex here. Alex Siegel 94 on Instagram. I'm a cannabis manufacturing researcher in Northern California. Kind of doing consulting and studying common cannabis manufacturing techniques, and kind of looking for ways to add value and help improve quality wherever I can.
Awesome, man. Thank you so much for joining us. I know you've got some really cool stuff you've been working on that I think directly relates to what we're talking about, and I think we're definitely going to touch on that later. So very excited about that. Who's up next, Brad? Brett. You're muted, Brett. Hit the mute. Nope, you're muted, bro. There you go.
They did it
There you
for
go. What up, buddy?
My first name's Brett. Everybody calls me Bird. That's my last name. I cultivated flower for about 10 years and started making hash and rosin about 5 years ago. Learned from a lot of really good hash makers to elevate my game really quickly. And I like mostly producing temple balls and rosin.
Awesome, man. I'm super stoked, Brett. I know you're a wealth of knowledge. Last time you were on the show, you blew all three of our minds, and you know, I'm really interested to hear what you have to say on this topic, being, you know, a real temple ball guy. So super stoked for you to be here, and I love your dogs, bro. Bri, who do we have up next?
We got the quiet one.
The quiet one, Tom. How you doing, bro?
Good. My name's Tom of Humphrey Hashish. I'm really just a home grower, and I've been growing and making hash for my own consumption since I was 18, 2009. And yeah, I'm currently studying horticulture and breeding at Oregon State University, trying to get deeper knowledge on the cultivation side.
That's awesome, man. And Tom sells, you know, that is a bit bashful. He does coffee and donuts with Shragam and Adam as well, and you know, has done deep dives into freeze dryers and the mTORs that they're pulling and where they should be and why. So if you're looking to analyze your freeze dryer information, reach out to Tom. He's got some really interesting stuff going on.
That's why I called him the quiet one. He doesn't say much, but when you hit the right topics, you know, it's just like, yeah.
Drop it. Absolutely. Who's next, Brad?
Let's bring on one of the people that started this whole conversation.
Absolutely. Kind, welcome, man. Thank you so much for taking the time.
How's it going, guys? Pleasure. Yeah, we make mainly solvent extracts. It all started from just a need to produce for myself. I think we touched a bit on that in our previous podcast. So I'll skip over some of that stuff. If anybody's interested, they can go back and listen to it. Or we touched on it on the oil and flower podcast. But yeah, we produce mainly solvent-based extracts. We've also been involved with solventless. Yeah, I think I have some opinions about what we're talking about. Some probably based on fact, some not. And I look forward to hearing what everybody's got to say and hopefully learning something here today.
We appreciate you being here, bro. I know you've done a lot for the Canadian space, and you know, for letting people understand quality and quality from your standpoint. So, you know, I really appreciate you taking the time. Bri, who's up next? Right on.
The other Canadian. Mike.
Absolutely. Chevy, how you doing, brother?
Hey guys, I'm Chevy, the Egyptian Hashishin in Vancouver, BC, Canada. And my approach is more derived towards hash than rosin and whatnot, even though I produce all sort of solventless products. And my approach is mainly about old school tech with new age influences, whatever that might be, from pressed hash to air dry to sift and everything in between.
Thank you so much for coming, Chevy. I know, you've got a lot going on, and I appreciate you taking the time. I think, your perspective and the way you look at things is different than the way a lot of us look at things. And I think that has to do with, your upbringing and where you were raised and the flavors you were raised around. And I've got nothing, I've gotten to spend a considerable amount of time with you, and I've got nothing but respect for you and what you're doing and your passion around resin. So thank you so much for taking the time, brother.
Pleasure. Thank you.
Absolutely. Brad, who's next? What's going on, buddy?
What's up, guys? My name's Waxplug on Instagram. I'm the co-founder of Chemtech and 9Cloud Cannabis. So how I started into this was more on the BHO side. I started back then when it was just glass tubes available, and I got my first closed loop it was one of those Grey Wolf Terpinators. I started the same way with working with older material, and it was darker, and that's how I got into taking the approach of how can I improve the color. Then it came down to flavor. So from there, that's how I came into co-founding these two companies at Chemtech and 9Cloud Cannabis. So at 9Cloud Cannabis, we do it's a Type 7 lab. We do BHO extractions, and that's what allows us to do a lot of the research and development to create the products that we sell at Chemtech, which is filtration medias or specially custom designed like closed loop parts, or like how we came up with the whole centrifuge idea to spin jars and spin oils that way to get them to separate.
That's dope, man. Where are you based?
We're in San Diego, California, South SoCal.
Awesome. Well, I appreciate you taking the time. I know you're going to have a lot to add to the conversation.
Mm-hmm.
Right, who's next?
We got the last, but certainly not the least. You know the man himself.
I do. Bring him on. What up, RJ?
What up? What up, everybody? I'm RJ, co-host of the Fires Fire Show, extraction specialist at Canada's leading third-party extraction company. Been making BHO for 16 years. Started with pre metal tubes and pre glass tubes. I'll put it that way, and had a lot of fun with it. And now happy to bring my products to the legal space and provide that quality across Canada. So happy to be here, and thanks for everyone for joining. And can't wait to get this party started.
That's awesome, man.
I was so rude. I forgot. I was going to save RJ till the end. We got one more.
Best for last. Somebody who we haven't had on the show yet, but I've got a tremendous amount of respect for. Rosenbell, thank you so much for taking the time today.
Thank you for having me. I'm Rosenbell in Phoenix. I've worked in Phoenix, Oklahoma, and California. And specialty is dry sift rosin. I started making rosin back in 2018, and then I pushed into temple balls in 2019.
That's awesome. Thank you so much for taking the time. I'm super stoked to get your input on your thoughts on the topic, because I know anybody who works with temple balls and things of that nature probably has a different opinion and a different view than some other people who are working with different methodologies. So the way I want to start this off is just defining pigment. Merriam-Webster defines pigment as a coloring matter in animals and plants, especially in a cell tissue. And that's really what we're talking about today, and how those pigments affect resin in terms of experience. And I want to hear your opinion on that question. I want to hear everybody on the panel's opinion on that question, and I think we're gonna get through that today. But I'm gonna open up the floor, and I'm gonna start with Bird. And Bird's been working with resin for a long time, as everybody on this panel. And I'd love, Brett, to get your opinion on pigment and your thoughts on if it correlates with resin and quality, or what are your feelings towards it? Oh, you're muted. You're muted, bro.
There you go.
Awesome.
My opinion on it is, from my experience, I'm not certified in anything, doctor and anything cool like some of the people here, but I I used to be a big pusher in saying that color doesn't matter at all, and you don't go by color. But I kind of I go on a little bit of a different side to that as well now, because I'll agree with the fact that the best stuff I ever had and the top stuff I ever had tended to be a lighter color. Not, and when I say a lighter color, I mean something that is very dark, versus something that's not white. And something's always been on the lighter side of for my personal opinion on that. But I would say you don't use resin color to judge the quality of the resin. Like you have over 80% of the resin ambered with no degradation to it. So I don't necessarily like to say either or. It makes it kind of complicated, because some of my favorite stuff was on the lighter side, but at the same time, it wasn't like the whitest stuff I ever had. So I don't just say color is determining on my preference of quality by any means. And once you start producing products, you start learning that there's some resin that comes out darker when you make it, and you appreciate it for that, because you've smelt it as you're growing it, and you become familiar with that terpene profile and appreciate that terpene profile, and you made it to the high quality level, so you didn't degrade it in the process. So I could see how people use it to judge color, because it could be a factor in how it was made. So it's kind of hard to throw it up there.
Absolutely, bro. No, I think I agree with what you're saying. Van Gyptian, I want to go to you, bro. I want to talk about, you've got a really interesting look at resin and how you feel about it. And I'd like to give you an opportunity to start touching on some of those points that you and I have talked about so much.
So I believe that color is part of an indication to quality. It cannot always be the main indicator to judge if it's that quality or not. I believe it's like 1 part out of 3 to assess resin. I tend to go for more amber heads when it comes into extraction, and the reason I prefer that, because it's part recipe. But I mean, part recipe is according to the resin color, it will go through different heat treatment. If we're talking like traditional or just pressing hash in general, just pressing resin heads into a massive hash. To me, the color would usually indicate how long do I need to press it. If it's more on the lighter side, I'll give it more time. If it's more on the darker side, I'll give it less time. And that usually delivers the desirable high that I'm familiar with, and so are most people who are into the hash high. That's what I could sum it as briefly when it comes into color.
Absolutely, man. And I think we're going to, start unpacking this a little bit, but I think that's a good place to start. Do you have some time to express I know you've got a tremendous amount of experience running through a tremendous amount of material, and you've got some pretty pointed opinions on this topic. I'd love for you to share them a little bit.
Yeah, sure. I mean, I would agree with Bird in starting off and just saying that if I looked at all the different resin that I've smoked over the years, most of the time, the most enjoyable ones were a lighter color versus dark. I'm not saying white, but generally speaking, that I think kind of touching on that. I think your original statement, yeah, pigment. I would agree. I wouldn't disagree with Webster's dictionary. I think that that's a good way to frame it for us. We're talking about a plant. We're talking about concentrated resins. What contributes to the character of that resin, the colors, the aromas, etc. Okay, so specifically, I think to kind of start and get to the heart of it, I think maybe Rick can point this out or help us on this. To me, cannabinoids and terpenes in their undiminished, like oxidized states are white. They're clear, you know. And so for me, to give you guys some perspective, I have not run 22,000 labs like Rick has, but our company has run over 1,000. So there's probably few people in the country besides Rick or the lab that I use who have looked at more analyticals and tried to figure out, well, you know, if I have 90% of this sample accounted for in terms of what we're testing being terpenes and cannabinoids, and you know, and readily acknowledging that that isn't the whole ball of wax, likely that, you know, I'm hoping, and I've had some conversations with Rick and the lab that we work with, you know, hopefully about bringing flavonoids to the table, and, you know, and testing for that whole group of compounds and probably others. And so what is in this other unquantifiable at this point percentage of this extract that we all consume? Does it contribute to the flavor? Does it contribute to the high? Is it good? Is it bad? Can I remove it? You know what I mean? So kind of that's how I came to like the perspective of it. Was this almost like an analytical challenge to see, like, can we produce something that says 100%, you know, that isn't like a distillate, you know, that is a true representation of the plant, like the plant's extract in terms of cannabinoids and terpenes or whatever. And so I guess that's kind of like from like more of a perspective and like research kind of thing. And then, yeah, like as an experience, generally speaking, yeah, like, you know, now that I'm able to remove these things for the most part, and other people in their various methods, solventless, etc., are, you know, able to remove, you know, we're not all smoking green hash anymore, right? You know, guys are being able to clean these things up. And so once you have them removed, I can taste them now that they're there. And so, yeah, I do have some opinions about, okay, look, I do think this is of diminished quality, or, you know, more oxidization than is desirable has gotten to this product or whatever. Yeah. And so I think throughout this, yeah, I'll be able to share some of those, you know, unpack some of that more for you guys.
Now, do you think that just to touch on what you said, are you able to taste them after they're removed because you now know what you're looking for? Is it like you can see the path? So now, okay.
Yeah, very much so. Yeah. Which I'm not saying is good, bad, or otherwise. I'm just saying is different, is identifiable. I think we all can, like, if there's, you know, if we're talking about even just bubble hash or whatever, and it's full of chlorophyll, it's green, right? It's full of a pigment. Well, that pigment does contribute flavor and impact something onto the experience, right? Oh, so I think the question is, and I don't think anyone's going to dispute that what we're talking about, that like no one really wants to smoke a bunch of green oil or green hash or green rosin. But what is desirable and what's not? You know, I think we'll all agree too that flat, plain white sheet paper, white rosin or whatever might not be the answer either, right? So,
RJ, what are your thoughts and experiences?
Coming from kind of both trains of thought, making a lot of solventless hash, kind of the old school way, not quite to the level of some of our peers on the panel, but then delving into hydrocarbon. I mean, you get used to a certain kind of hue that your resin has after a while, right? And then the whole kind of filtration thing, like Waxblog is talking about, came to bat, and then it was like, what are we really filtering? You know what I mean? Also, what are the constituents that make up pigment? You know what I mean? That's a lot to unpack. Everything from the pH of certain chemical constituents to oxidized compounds.
Absolutely.
I mean, so it's where do we even start to begin to what we take out and what we want to take out? I think it's interesting, like Murphy-Murray fractions everything and then reintroduces. That's a super interesting way to take it, the straight chromatography method. I think that's super cool. But then again, you know what I mean? In what ways are you putting Humpty Dumpty back together? I have a little bit of a different philosophy on filtration, which we can touch on a little bit later. But it's kind of what Kind was saying is it the oxidized and oxidative compounds that are affecting and having adverse or negative effects? And if so, how do we deal with that? How do we remediate that? How do I pull that back or turn the volume down on that? So that's just kind of what's brought me to Pigment, especially being able to play around with different filtration techniques and media, and then try to still achieve a specific goal.
Absolutely. Waxplug, do you have any thoughts on anything to add? Like, what's your experience with pigments? Oh, you're muted. You just got to unmute yourself, bro.
One thing we've done at the lab is we did a no CRC run, and then we did them with clays. We did one with only silica. So just to start getting an idea of what's being pulled. Right off the bat, one thing I noticed was that terpenes would be the same on no CRC and CRC when it came to just about all of them except carbon. So silica, clays, luminous all seem to allow the terpenes to pass through. But the flavor on both of those extracts was still different. So that's what led me to realize that all the flavor doesn't rely only on terpenes. These pigments also have a flavor to them. And all those mixed together is what we actually taste. So from what I've read and studied is the pigment, like you take a fresh plant and you extract it, it's going to come out pretty white. It's like a fruit. It hasn't ripened yet, basically. So these pigments are like flavonoids that the plants produce as they ripen up or as they need to send signals to attract certain bugs to them or whatever it is. Whatever their environment is how these plants produce these pigments. And that's what we end up extracting in our extraction. It's not just a combination of when we look at color to judge it, it could be pigments which are fresh and not oxidized, so the flavor is good, or it can be oxidized version of that pigment, which is more on the darker scale, and that has more of the rancid or weird flavors we tend to get. So I sent a
Are you pulling things you can't account for?
I'm sorry?
Are you pulling things that you can't test for? Like you're saying, like you have all your list of terpenes and everything's coming back either the same, or I've seen a couple tests come back with higher terpene ratios because we're actually pulling some stuff out.
Yeah.
But so are some of the things that we're pulling things that we can't quantify yet?
So one thing I've done is 710. I sent you a picture of a bunch of rings of colors. Is there any way we can display that right now?
Yeah, for sure. Brian can grab that. Hopefully.
So just to explain what we're going to look at, what I did here is and Alex hopefully can help explain more after this. But basically, I did my runs through the CRCs, and afterwards I took a UV light and I shined it at the media, and I could see the pigments glow. So that's how I was able to tell, like, what is this media grabbing? What is that media grabbing? And then I started noticing patterns, like certain pH would stop a certain color band, or stuff like that. So that's how I started kind of dialing in the medias as to which one is better for what extracts. And then it was just after extraction. So here would be like an example of the Chlorosorb. It's a media we sell. The chlorophyll glows red under the UV light, and it shows that it's being selected for it. If you were to hit it with the regular light, which would be the other picture I sent, it would just look like regular right there. So at the minute you hit it with the UV light, you see what pigments the medias are actually picking up. There should be another picture down there. If you can go down, there's one that has more of a rainbow. That's the carbon. In the bottom, it shows that it's stopping that baby blue band. And that carbon is of a higher pH. I think it's a pH of 10 or so, or 8, around there. It's pretty alkaline. Here we're showing the clays, what they're grabbing. So you start seeing the colors. So that one that has just the red and green around it, but it looks blank in the center, is the W1 underneath. And then the picture that you go under, it would be another clay basically, but with different parameters. And you can see the other picture, the next one, you'll see that that one actually grabs all the colors. So that's why when you CRC, you get some stuff that tastes like flavorless, is because some of these medias are grabbing all the colors, you know, and you don't want to grab them all. Sometimes if your stuff is pretty fresh, you only need to remove the chlorophyll band and the other band, you know, you want to keep those other flavonoids.
Absolutely.
Those combined will give you the what people refer to as the non-CRC flavor.
Interesting.
And I think Alex, he knows way more about these pigments and how they reflect. He sells the pigment tracker actually.
Before we jump into the pigments deeper, I'd love to get Tom's look at this. Tom's been super helpful for me this week, getting my head wrapped around it. And Tom, I'd love to get your take on what some of these solventless or solvent extraction comments are saying around CRC and pulling these flavonoids and that truly affecting flavor, and how does that translate to you into your views in the solventless world?
So I mainly done solventless, but then I've also have experience with solvents. And I guess how I perceive the color thing or the pigment thing is with solventless or cold water extraction, we're focusing on separating the glandular trichome head, where in a solvent extraction, you are using a solvent and running it through all the plant material. So there's more of a chance to pull parts out of the plant material, in my mind, than a proper cold water extraction. So
that's correct. Just to add to that real quick, when you do like you're saying, you wash the glands off. If those glands are already amber or more mature, that's usually where the pigment ends up in the rosin, because technically
exactly.
if you wash it through the bags, it should get rid of the other pigments.
Yep. So that's kind of where I've been making hash since 2009. Obviously didn't have a freeze dryer. Most of my hash was pretty dark, but I smoked it all. If it was green, I wasn't touching it. If it's green, I throw it out. Like, I totally agree with that. But then when it comes to solvent extraction, since you are hitting all of the plant material, I do want to see some dewaxing and something done to pull out what you could extract from the plant material that you don't necessarily want to smoke.
So those can actually be pulled with just having moisture and acidity in the clays. That's why when we run through CRC, we tend to get more clarity in the oil. Just having those two factors in there, it's gonna start to dewax the oil. What most people I notice when they refer to dewaxing and they get that white pulp that settles, I've sent it into test. It's actually THCA that's crashing out of the solution.
Okay.
And there are some fats, but if you just run it through a CRC, it's such a little amount of fats that come out that it's pretty easy to remove. It would be more of a problem on hemp, I would believe. Hemp tends to have usually more fat to it.
Rosin Bell, I'd love to get your view of pigments, being somebody that works primarily with temple balls and starting with dry sift. How do you view this topic?
It's kind of complicated. One end, I went with mostly dry materials, so I see a higher percentage of oxidization. But I do think that you guys are right. We added pigments being other things like flavonoids, and carotenoids is the other one. Flavor as well to the oil is definitely flavor coming from them. I want to say things like garlic terps, which we know aren't terps, are most likely, in my opinion, something like a flavonoid. And so flavonoid testing, I think, is going to be the next big thing with trying to figure out pigmentation.
Interesting. So speaking of testing, Rick, you've been, listening quietly and absorbing the information. I reached out to you and asked you to be on the panel and was absolutely stoked when you agreed to join us. Overall, just absorbing what everybody's saying, what are your thoughts on the topic so far?
Well, I think where I feel the pigment, I think, really comes into play definitely is, I don't know if it's 100% on the quality. I definitely agree, though. The majority of, I brought so many different hashes I have here, probably 100, and the majority of them that I do prefer are certainly on the lighter side. But it definitely has to do with the process as well, and knowing the flower, the material you're working with, right? Is it outdoor? Is it grown past maturity or later into the maturity or whatever, right? And every kind of genetic does express itself a little bit differently, even within its own environment. If everyone here had the same pheno, it wouldn't all be the exact same after they're all done growing it, right? So I think it definitely does play a factor, but I don't know if, as I think Kind and even Chevy said, it's like one of a few different factors. Now, what Waxblood was saying was pretty cool, and it's too bad, I'm different countries, and because I'd love to even get some of that, what you were showing in those pictures. I'd love to even test some of that. I know it's clay, but whatever else is in that, we've started on our flavonoids method. We have it developed now. We've been doing some. I don't think I have any samples here.
I think I can work with you on that, Rick. I think I can work with you on that.
I'd love to.
We already sent stuff. We already sent stuff to you, so we just got to work out.
Oh, really?
But yeah, we can talk about that. We can talk about that after. But yeah, I can send you some powders. I can send you some powders for sure.
Yeah,
I'm getting Wax Plug's entire lineup. It just arrived today, actually. So
serious,
we can
yeah, I was gonna say a lot of those medias will grab different pigments. So when you hit them with the light, you'll see they're all gonna glow different, and it's gonna tell you what it's being selected for, and that's how you know which one to use.
So right now we're at about 15 flavonoids that we have on our list, but then we're going to get into the ketones, aldehydes, esters, all that kind of other stuff, right? And I just want to work with great guys like you and ladies and everyone, right, that really has a passion for the plant, because I'd love to try and figure this out. There hasn't been enough R&D, right? And
absolutely.
Nobody really knows. We think we have an idea. There's stoner theories, all that kind of stuff, right? But is it actually true? If Waxbug, you sending out that stuff for testing and everything, that's great. I love hearing that. And Kind's doing tons of testing too. That's awesome, because we really need to try and, as a collaboration and stuff, try and figure it out ourselves, because no one else, none of the Chads or stock companies that think they're a cannabis company, they're not doing any of that kind of
100%.
stuff. So that's where we got to do that and try and figure it out. I don't know if it's a flavonoid or not. It's interesting that you say you can taste the difference, right? And Kind I've talked to a few times, and he says how he can taste that oxidization. I don't know if I've got enough of a taste to figure that out yet. I mean, maybe if something tasted really bad, I'm sure. Obviously, there's certain stuff here that I love the taste of more than others, and there is even a couple, like even this one. It's got 23% terps in it. When you look at the terps and you look at the profile, it doesn't seem like there's anything special. Yeah, there's a lot of terps, but it's all the typical players. But there's something in that. So I really think it's a flavonoid. I'm not sure yet. We're still working on that. I'd love to try and figure that out. And there's a few other, even some flower cultivars that are on the market right now that have a distinct taste. Yes, a lot of them smell good and everything, but not all of them have that almost leaves an aftertaste, a nice, pleasant aftertaste. So I really want to try and focus on that. But as Kind said, I got pure terpenes right there, and they're clear, right? So, I don't think the terpenes itself are adding.
Can you hold them back up again?
What exactly is flavonoids, which definitely I think are a big factor in the pigment.
Yeah.
Can you hold that product of solvent, solventless? When we're talking hash, I don't really know yet. That's something we're still trying to explore.
Rick, can you hold that jar of terpenes up again just to show everyone? Oh, you might have a little bit of a delay. Are you there?
I'm not sure if anyone else can hear me now.
We can hear you. I don't know if you can hear us.
Yeah, right. All good. We can switch back over. I wanted to ask Adam what your thoughts were on this topic. Just
And I was going to say, just before we get into it, Adam's got a really I don't know if many people have picked up on it, and Adam has said this once, but he's really had my head spinning since we've talked to him, and since I've been diving deep into your page. The idea of, is amber heads really an amber head? And I see Tom smirking at that because I think he's had the conversation as well. So I'll let Adam go into it.
Well, I also don't want to forget about, I wanted to talk about limonene because I feel like there's some people that have more experience with than me on, like what Tom was saying. We really do just specialize in particle separation. So we're breaking the anatomy of the trichome apart and separating it by size classification. And there's not really breaking down, dissolving anything and refiltering and removing of anything. So I don't know. I want to talk about limonene just for a second before I go off on that, just because I feel like it relates to the pigments a lot. Like I've noticed in orange flavors, you have to go a lot quicker. You got to really be good at storing it, because the things that are heavy in limonene seem to turn a dark orange fairly quickly if you're not careful. And I just felt like maybe, and then I was reading into like some essential oils websites. So like doTERRA, one of them like even says that limonene oxidizes quickly. Maybe we don't need to say oxidizes more quickly. Maybe we like a freshness, duration of freshness more so. But anyways, maybe we could all just like a dialogue about that just for a second. But I could, or I could just go off on.
No, I'd like to open that up first to everybody, and then get back to you, Adam, if that's okay. Do you guys? Does anybody have any experiences similar to Adam?
I was gonna say, I just before we get into that, because I'm like the science geek about it, and so when we talk about the terpenes and then the chemical compound of it, and then as it's exposed, a single hydrogen bond changing from, if you're into chemistry, a cis to a transformation can potentially change the effects as well as the flavor and the color. And then down the road, we'll talk a little bit to Alex about that, because I think that the science is quite important there. But yeah, so let's open it up a little bit as, limonene.
Yeah, does anybody have any experiences?
Well, I think that I have one thing that I could say about that. I think that you're right about the flavor of the lemon strains being something that you have to treat with some care. But I don't necessarily think that limonene or even pigments are the source of the qualities that we're talking about, but they might be indicators of them. Where if you have a pigment, you might also have other contamination that is similar to the pigment. That pigment doesn't have to be adding all of the flavor that we're talking about or adding any effects. That pigment could just be adding the color that allows us to identify other things that could be in there. So like the carotenoids, which are red, our industry is kind of allows them to be in the plant. We kind of use them as an indicator of quality in some ways, where if you have a light yellow extract versus a green extract, you're going to go for the light yellow. Carotenoids are very similar to terpenes. And so, if you're looking for something to correlate with a high monoterpene extract, the carotenoids are likely to do that because the properties are just more similar to the desirable terpenes. So that doesn't exactly directly relate back to how you need to treat the strain that has limonene in it. But, I just think it's kind of important to look at that, where like these molecules might be only a 0.01% of the mass or 0.1% of the mass, but they could be contributing a lot of color and almost no effect whatsoever. Like chlorophyll, for example, is not volatile, and I don't think it even has a boiling point. I believe it degrades before it boils at like 200 Celsius. So, we're not going to be smoking chlorophyll. We might be smoking some of the breakdown products of chlorophyll, but it could be that because chlorophyll has certain properties, when we end up having chlorophyll in the extract, we end up with other contamination too, like chunks of plant material, and in the ice hash example, or just contamination that's more polar than THC in the butane extraction example. So yeah, that's kind of my thought on that, the pigments might not actually be the quality; they're kind of an indicator of the quality. If that makes sense.
Interesting. Kind,
I
do
love
you
that
want
thought. I love
to
that thought.
comment?
I agree with that.
Yeah, I kind of had a comment to touch on kind of like what Waxplug's saying and what's kind of being put around now. I didn't actually think to use UV light on any medias or any different filter types or whatever. I do recall actually guys over the years putting the UV on bongs and seeing various colored resin in different people's bongs, you know, and from what different things they were smoking, I guess, and maybe temperatures and whatever. But yeah, very much so. Like while trying to break down, you know, what it was that I wanted to pull out, which I definitely don't have down to an exact science by any shape or form. You know, I had to look at what it was. Like green is obviously chlorophyll. You know, like the oranges are the keratins. I think deep reds are oxidized compounds. Like if we look at our blood, right, like a deep rich red is from the oxygen, right? This is a theory. You know, I think so. Some of these deeper, richer reds, closer to browns, are actually, you know, just like signs of some of these oxidized compounds that.
I'll interrupt
You
you
know,
there for a moment, just as far as blood.
please.
You're talking about hemoglobin pigment.
Yeah.
So when oxygen binds to it, you're talking about oxygenation, and that's when it actually does turn red. Otherwise, it goes purple or almost like black.
Yeah.
And the
Okay.
same
There you
thing is
go.
actually true for chlorophyll. Chlorophyll is a porphyrin ring that has a magnesium molecule in the middle of it, sort of like how heme has an oxygen molecule in the middle of it. So that porphyrin structure, which is basically like a big circle, is very good at absorbing energy, and that's why it's in tons of plants. So like as soon as that magnesium molecule leaves chlorophyll, it starts to change color, and it loses its ability to absorb light kind of as efficiently, and so it will turn more of like a light yellow and then or like a light green and then like a light yellow. And you can see that if you were to go outside and just extract some grass and then leave it out on a windowsill for an afternoon, it'll go from being a bright green color to being a more a darker shade of green. So yeah, blood is a great example for that. I think that's a great comparable thing. And blood probably fluoresces very similarly to carotenoids, to be honest. So under UV light, I would bet that blood maybe looks blue, just as a random side thing. But what you said too, I think that oxidized compounds is actually right on. If you can go 710 doctor onto the carotenoid slide that I sent you, or some of the pictures that I sent you. So this is a slide that shows, sorry, these are just kind of pulled off of Google. Go to the next one, if you would. Next one, one more. Do we have the, so carotenoid. So this is the very non-polar, very monoterpene-like pigment called carotenoids, more fat soluble even than THC. And you can see at the top, we have this compound lycopene that is, or not all the way at the top, but you have this compound lycopene that's split into these two different carotenoids. And what that means is that the plant has some amount of lycopene that's being synthesized so that it can be used. And one of the things that it uses it for is as an oxidation, as a compound that will handle oxidation and cellular stress. So if you can see here, the beta carotene, if you go to the right side of that fork, is oxidized into zeaxanthin and then anthraxanthin, and there's this cycle called the xanthophil cycle. It's basically just a way to handle oxidative stress in the cells. So you have these two compounds. One of them is a very non-polar monoterpene-like compound, and you have an oxidated or an oxidized version of that, which would be the xanthophils, and they kind of sandwich THC, where THC is in the middle of them in terms of polarity. So you end up with this situation where you have the oxidized compounds. They have a function in the cell, and we see them in all of our extractions. But if you do a very non-polar extraction, you can kind of avoid the xanthophils and the more oxidized compounds because they have that oxygen. And at least this is all our kind of theory on it. Whereas it's very difficult to just do like a very cold propane extraction and avoid getting the lycopene or the beta carotene because they are very similar to the monoterpenes in their properties.
So Alex, you just like you gave me a little bit of a hard on here, by the way.
Okay.
Because the way that this is broken down, and like I feel like I'm back in lectures all over again. And the fact that you've got lutein and zeaxanthin, these are yellow pigments that are actually found in your eye that are the protective pigments for your rods and cones that prevent macular degeneration.
Yeah,
They're also
yeah,
found in almost every single pigmented fruit and vegetable.
Yeah, so like this is where we get vitamin A from.
That's crazy.
And like retinoic acid, I think, is used in skin treatments as well. Retinol is what vitamin A is made from too. So there's there's like these molecules are pretty ubiquitous. Like if you go to a plant almost anywhere, these molecules will exist with other pigments like chlorophyll. I think that the carotenoids alone, it might be carotenoids and xanthophylls account for like 25% of the yellow pigment in plants that we see, and the other 75% is the breakdown of like of the anthocyanins. Sorry, I forgot the name of it. Anthocyanins, and then the chlorophyll breakdown products that are yellow. But for propane extraction, so for the butane extraction side, this is the red. On this diagram here, I think are a good place to start for what are the red compounds that are there in new material, no matter what, and then what are there in the kind of older oxidized material as well. Because we see this in I have here some samples that we separated with chromatography. I'm going to see if I can hold them up.
Let's blow them up, Brian. Just 1 second. We don't have you full screen yet.
That's okay.
So does pigment relate to age?
So if you think about like a very young tomato, what color is it? It's green. And so a ripe tomato is red. And there's a combination of reasons for that. Part of it is the chlorophyll breaking down. So the chlorophyll, instead of being a bright green color, it goes to a more kind of in the background yellow color. And in the end of life for the tomato, the carotenoids kind of take over the job of absorbing light from the sun because the chlorophyll is starting to die, and the carotenoids then come out, so the tomatoes turn red. And there's all these other things that happen at the same time, where like the amount of fats in the plant increase in general, the amount of carotenoids and xanthophylls increase, but the chlorophyll kind of breaks down and becomes less green, and turns some more of those brown colors. So I think that there's probably a plant out there that ages very similarly to weed. It might not be tomatoes, but we can probably start by looking at these just very kind of ubiquitous cycles of pigment that are in plants, and kind of look for when are they changing in the grow cycle, and what do we have to do in the manufacturing to avoid them.
Interesting.
I don't know if you guys can see these.
Let me ask a question here.
Sorry, go ahead.
So at what point are, in some respects, they're functions of degradation, and then other respects, they're compounds that have kind of all the value for like, to bridge the gap between our solvent and our solventless homies up here on the panel? Where at what point, like, do in solvent we view them as functions of degradation, but in solventless they're actually the building blocks for all the effect that we want?
So I think that the solventless people are mostly getting the effect still from THC. I don't know for sure, but I think that the pigments are, in my experience, the pigments are not vastly different. It's just how are they delivered into the extract? How does the contamination get there? Like for the solventless people, has anybody here heard that chlorophyll is water soluble? Has anybody heard that in the industry that, water chlorophyll has a if you have like wet weed, and you extract it, it'll come out green.
Isn't chlorophyll non-polar though?
Chlorophyll is extremely non-polar, and It's a kind of industry thing where people, because it's more polar than THC, it does get this kind of wrap to it. And I think that also when you have live weed, you have a lot of live chlorophyll, and so it's very bright green. So you extract that and you kind of correlate the two, but it really just comes from the live chlorophyll. Point being that for solvent extractors, you don't have to worry about solubilizing the pigment, but you do have to worry about knocking it off of the plant. And chlorophyll comes in little cellular organelles called chloroplasts that are like, I think that they're 5 to 10 micron or something like that. So you think they would just go right through your bags, but they don't. They get caught in the hash themselves, and then doing things like blasting water onto it to get the green foam to kind of accumulate. And I've seen people even just scoop it right off the top. That's all chloroplasts. That's not solubilized chlorophyll. So compared to the hydrocarbon extractors, you have to worry about a particle of chlorophyll instead of worrying about a solubilized chlorophyll that you have to filter out in a powder, like what Jordan was talking about.
Can I ask you a question? So in a freeze dryer tray, if you let the water run, it tends to take the plant matter. So it's non-polar. Why do you think it would pull that more so than the resin?
Could be gravity, or just the resin is kind
So
of
like a density thing?
Yeah, I don't know. That's a good question. It could be that the resin is kind of...
Water does some funny things, because water is rather interesting as well on a scientific level, and the bonds, the covalent bonds and things that are happening there, hydrogen bonds.
Absolutely.
Yeah,
Rosin Bell, I'd love to get your input on this topic, and I know you had something to add before.
Yeah, I just had a question. Circling back to limonene happening quicker. Is that because it's a more solvent terpene and it's breaking down material in the one.
I think she was asking if limonene is a higher solvent terpene. Rosin Bell,
It is. It definitely is. Like, I mean, some people use it to, I don't know, RJ, if you use it as one of your cleaners for some of your equipment.
I don't, but when I run CRC, I noticed that it's definitely one of the first to elute. Like, I think it's the fastest terpene to elute. That's why, like, over CRC products have that just banging lemon, like, cleaner taste, just because, like, if it's going to be one of the only thing that elutes through, it's going to be super concentrated. So I would definitely have to agree. And maybe that's why it also likes to oxidize so quickly, potentially. I don't know.
Yeah, I'm not too sure. We do have some clients that use limonene to clean their equipment between batches, and then they ask us to test for the presence of that and make sure, because they're GMP, and make sure that there is no limonene or anything else left over. But specifically, that's what they're looking at.
Interesting.
How do you confirm there's no limonene in the product when there's limonene in the products themselves?
No, they're taking swabs of the equipment after.
That's very GMP.
Yeah.
What's been your experience, Rosin Bell, with working with that high limonene material?
I just came back in.
Oh, pardon. What's your experience been working with material that you've experienced as high? Oh, maybe she might have just dropped out.
Well, limonene is supposed to be extremely nonpolar, right? It's supposed to be more nonpolar than any. I think it's the most nonpolar of the terpenes that we have. So I would imagine it's trapped in the trichome and it's not affecting your solventless extraction much at all. It's probably a correlation. Maybe if you can smell it, it's a sign that the plant is broken apart, or maybe some of those cells have broken down. And so then when you go to whip it all up and get your hash off of it, you're just breaking up some of the plant material itself. Like, if you imagine someone on like a very small level just went and like poked holes in the plant all over it, so you can smell it more quickly than when you go to shake it up, you're going to get more contaminant cracked off of it too, just from those cells being open. I've seen people. There was a lab that had a really high quality grower who was sending them fresh frozen that was so frozen they had to grind it up with a hand grinder in order to get it into the machines. And just the process of doing that and cutting the plant material up basically doomed the hash to be a B grade look to it. Even though it smelled amazing and tasted great, it still that just had a strain of chlorophyll released into it. And we think it was because of that. And the same thing was happening on the solvent extraction side too, where they were just always getting darker extraction. And
anyone unpack that?
Sorry, what? So Billy Cossack says limonene is produced outside of the trichome heads. Interesting. So the terpenes are not inside of the trichome. Are you sure it's not at least?
We don't know that is factual. We just
well, a lot of the stuff isn't made in the trichome. A lot of it is made in the plant, and then they use the trichome as a. It secretes into the trichome, I think.
Adam, tag, you're it.
We're not
from what I've read, what makes cannabis unique genomically is the vesicles that are released from the disc cells, which subtend the gland head. So the disc cells are like at the bottom with the other cells. The stalks are really just like elongated dermal cells, and the head is completely different in function. It stores the secondary metabolite, but the vesicles are actually the secondary metabolite, the terpephenolic compounds that are what make cannabis unique, because obviously other plants produce resin, non-granular and granular, but what makes cannabis so special is the terpephenolic compounds, or better known as cannabinoids.
Cool. Yeah, and I don't know if the carotenoids may be leaked into the trichome head as well. If you take extract, if you take keef and you extract it with a non-polar solvent, there's definitely some yellow color that comes out. I don't know if it's yellow color from trace plant material left in there or if it's yellow from the trichome itself. But I think that the trichome ambering with age could be carotenoids being transferred into the trichome themselves. I think that someone has characterized everything inside of a trichome, and we could probably go and look to see if there is a carotenoid in the trichome as well, because that would be
what I've mostly read is plant journals from Paul Malberg. He was the dude who had the only license with the U.S. government to study cannabis from the 60s to the 90s. So they deep dive into gland, all the science on how the cuticle of the gland head is created by the vesicles I was saying are the metabolites, are partially, they're different functions, but partially are they are transporting themselves and oxidizing against this sheath of the cuticle and building up so that it has stably, it'll be more stably structurally sound to hold and store more oils, which was cool. But
well, yeah, it would be cool to look at his research and see if he saw carotenoids in the trichome or if they did not see carotenoids in the trichome.
Yeah, that would be cool. I did want to just say, and then I'm done on the trichome stuff, but I notice in my hash when I put it under the scope, just quick, fresh water, you only have about an hour to look at this stuff under the microscope before it starts to go bad. But I think that the trichomes are, and whenever you're looking at them and when you're harvesting them, they're still, contiguous gland heads will be in different shapes and sizes relating to their life cycles, right? So you'll have full, whatever, quote unquote, ripened gland heads that those cells are starting to, it's the part of the process where it starts to apoptosis, whatever you call it, cellular degeneration.
Yeah.
So I think that amber disc cell is refracting through the gland head, and I've had talks with macro photography, like Eric Nugshots is who really has shown in good visual images different, because the light obviously has to do with the way that everything is, you're seeing everything. And so really whenever you're looking at an amber, quote unquote, amber trichome gland head, really what you're looking at is the disc cells at their last stage of their cellular cycle, right? So.
Interesting. Chevy, I wanna switch it over to you and ask you, as somebody who works with a lot of aged and plants that are run a little bit longer. Once you get to know a cultivar, are you able to associate the flavor, the color of the resin with a certain flavor that you're going to expect?
I don't think that is the case always.
Okay.
And so I would like to make a clarification first. When we're comparing the colors, hash is concentrate, but what hash
Oh man.
Bad timing.
Are you there, Chevy? Seems like he's still there. That was pretty epic. Are you back?
Mhm.
Yeah, we got you now. Start over.
Yeah. So when it comes into color, just a subjective observation, the darkening of resin, aside from the resin color, anything with enough heat will darken. Resin that has been dried properly on a flower, that will be the cured part. And once it gets pressed, this is where the aging starts to happen. So the aging and the curing part are separate. What does the color equate to when it comes into hash? So the chemistry of hash requires everything to be intact, from the waxes to the oil content to the flavonoid and carotenoid. Once that process happens, there is a chemical reaction that happens within the hash that forces it to darken. The light could not penetrate through it as it would when it's loose resin, or when you squish that into rosin or clarify it further through hydrocarbon. So color is not always subjective to the flavor. I think that would be mostly on the cultivar. How old was it? You're gonna get a variant in the flavor, but it's mostly the high that counts.
Interesting. And
So
so,
what I'm
go ahead,
yeah,
please go ahead.
Oh, go ahead first.
No, I just think it's really interesting. Like I love unpacking the way you're looking at it. Bird,
Yeah.
do you have any comments on what's been said as far as what you've seen with all the work you've done with resin? Oh, you're there. You're muted. Yeah.
No, there. Now we're good. Yeah, it's really pretty much like you guys are all covered it pretty well.
Yeah.
Pretty much is how I feel. It's not a determining factor 100%, but it's something that you use as a selecting factor, possibly, to help guide you in the direction of what you're evaluating. Without all the background knowledge of everything, it can help you evaluate things.
Absolutely. And so, is your when you're pheno hunting and you're doing separate washes and you're seeing you're watching your fresh press from two different phenos of the same cultivar cure out and become different colors, are you associating that with different terpene profiles, or do you think that with this conversation that it's just a lot more going on in there?
Not every time. That's the problem with what you can't do, is associate one thing and say this is 100% of the time that what you see. But I have seen consistencies in certain terpenes, such as like the orange terpene that you find be more elusive for washing, coming out in a lighter color. No matter what I tend to do when the flower is picked at its perfect harvest time, just like everything else from the same farmer, and it just tends to be a little bit darker of a color, and then that's for the orange terpene that I tend to come across. But yeah, it's like I said, you don't do that every time. That's not going to be 100%.
Yeah, 100%. Absolutely.
It's like everyone always says Tangy runs dark, you know what I mean? And like Trop runs dark, and just all these like, so it's got to be just the certain whatever, you know what I mean? Whatever it is that actually constitutes that flavor also has that effect on pigment. So then it brings us to the question, is pigment flavor? Yes, I guess.
I kind of agree with that. When you break it down to the definition of it, of what's happening and what we're tasting, that it is a flavor, and it might be good, it might be bad. I think that's part of what we're finding out.
What I was going to say, you can have all flavors be pigment, but not all pigment be flavors.
Yeah, because you can get pigment just from having sun grown, so I don't think that particularly adds flavor. It might increase terpenes, but I don't know. I don't do with why pigment is darker.
Which goes to what he said, was not every pigment would be flavor, but there might be a correlation to some of them.
I have an input. I have an input on that matter. Basically, the way that I see it, it's a part of the chemical matrix that are required for the hash to transfer further to a higher state. I would like to compare that to wine. So when they're making wine, they would mush the whole grape with the skin, with everything. And from there, the whole compounds that has been refined into a mush creates what, for example, red wine is known for its characteristics, compared to just fermenting the grape juice itself. So in terms of hash, they might not have a value themselves, but they are part of the chemical reaction that happen throughout the aging after you have pressed the resin.
Does anyone want to comment on that?
Yeah, I agree with that. I actually did a little bit of training in the winemaking industry, and it does come down to that. They have a lot of techniques, and that's how they kind of make each kind of wine, So it would be kind of like, for us, the same thing is, it would be a sort like a type of extract, So filtered would be like a blonde beer, whereas non-filtered would be like an IPA beer. And one thing that got me thinking of, I've been meaning to try this, is maybe we should be aging our HTEs, our sauces and terpenes, to see if they age the same way as wine does, since they are pretty similar. There'd be something new that ends up evolving.
5-year-old live resin, so it's not live anymore. And it's definitely changed a lot, right? But it's got a lot of the same notes. You know what I mean? It's just it's still tasty. It's not rancid, right? It's just
that's what I wanted to get a testing done, just so I can see the numbers and get like an actual, start looking for the pattern as to what is the aging doing. Is maybe it's the way we store it as well, like it can't be in UV light, it has to be away from oxygen, and
definitely light is something you don't want near the hash.
One time we lost a freezer, like a small freezer, because of electricity problems, and it was full of mandarin, just heavy limonene, very citrusy, and it smelled like fermented, like just it wasn't even that long, and it smelled, just a few days after, because we were checking all of them and everything was fine, but that one overlooked it, and that one went back into the garden. But I thought it was interesting that it smelled fermented.
Did it start to mold, maybe?
No, it wasn't. It was just, it started the I don't know why, but it just started to smell like it was fermented. Maybe it was molding. It was probably molding.
Was it old, fresh frozen, or material?
Well, it's fairly fresh.
because I have experienced that with a papaya that's been in the deep freezer for 2 years. It started fruity for the first few months and slowly started to take onto cheese and then into some feet fungus type papaya. Like as if it have it turned basically into cheese. It was sweet and fruity at the beginning, and as it have aged, it turned into the same notes you're explaining.
So Rick, can you do some carotenoids testing?
So we have not got any of those standards to be able to test that. But after this roundtable, I think I need to look into seeing if we can purchase some of those standards to start doing some of those method development.
It should be that an HPLC DAD will be able to do it. You might have to use a different column, which I don't know how much of a pain in the butt that is for you guys.
We've got many different columns here, right, with multiple different machines. But
cool.
we are doing flavonoids on the LCMS.
Okay. Well, yeah. If I haven't even, I have a quote for like $400 a test from a lab to do carotenoids testing, and they have like a list of maybe 15 that they identify. But I don't know what the specific carotenoids are.
Are they testing that in cannabis already, or are they testing it?
No,
with
it's just some lab. I don't know.
So can they even, are they even sure like that method is suitable for cannabis? Cannabis is such a complex matrix.
Can you talk about, Rick? Can you take a moment to just talk about the complexities in testing and the issues that we faced in Canada with a myriad of testing clinics being created and testing for what would probably be arguably the wrong things in the wrong areas?
Well, yeah, I think one of the main issues is that a lot of these labs are, pharmaceutical, environmental, water, whatever, and cannabis, and their methods, their equipment, their staff, they're not all trained specifically for cannabis. The methods aren't developed specifically for cannabis. It is not the cleanest matrix to work with in an analytical lab. It's not a sterile product by any means. It's amazing. I love it, right? But it is difficult. And I'm not a scientist, right? We've got a great team, and I've helped provide them with a lot of cannabis education, trichomes, different matrices, all these great guys and girls that are on this round table that make all different kinds of products and doing the innovative stuff that, as Waxplug was showing, and, that stuff is really cool. But as far as testing, to try and nail down the most accurate and sensitive method, you really have to be very specific. And then what we get, especially edibles, for example, right? So we've got like a high sugar, a high fat, and a liquid method for edibles. Chocolate can really mess up. The quality of chocolate can really lead to it not being suitable for a method. And then we have to do further development and stuff like that. So
what do you mean? What do you mean by that, Rick? That quality of chocolate? Do you mean the actual ingredients that have gone in it, or too high of cocoa, too high sugar, too high raw?
Specifically the quality of the actual like cocoa or whatever it's exactly called, that can really change how the background noise and all that kind of stuff on the instruments are. It really can affect that, and then you can't really nail down that sensitivity. The edible method is very sensitive. I think the LOQ is 0.00025. So it's very sensitive, and the little different ingredients that some of these clients are putting in can definitely affect it. And then as far as what Jameson was asking, like a lot of Americans are on this, we have 96 pesticides that Health Canada requires to test for. And that has to be done through two different instruments, an LCMS-MS, a GCMS-MS. So it is very, time consuming. The method itself takes a while to do one sample even. And then all the quality controls that we have for like blanks and duplicates and spikes, and and other kind of references before, in the middle, and at the end of every batch of client samples to make sure that the instrument is working properly, right? Daily calibration and all that kind of stuff.
Absolutely.
So there's a ton that goes into it, and that's why it's so great to see, everyone on this panel that's doing testing as well.
Absolutely. I want to switch over to you and ask you a little bit about, your opinions on what you've heard so far and your experience with cured resin specifically. As a more solvent based extractor, would you ever see the viability of letting a plant material or isolated resin cure longer before you were to run it through your extraction methodology to improve the flavor experience?
Generally speaking, I would say no.
Interesting.
I would prefer, and that's kind of how my original statement, kind of in terms of that Instagram post, came about, was these prospective consulting clients and trying to facilitate some stuff, and I finally got to see a sample, and it just blew my mind what they wanted to do and what they wanted to work with. And yeah, it had been sitting in a barn for like 8 months, and I mean, it could have been worse for sure. But if we're going to talk about trying to make a premium product, it's just not the way. So okay, so the answer is somewhere between there and fresh. Now, everybody can have their opinion of what that is and what that brings to the table. For me, I kind of like to keep it to processed within 2 weeks to 3 weeks of being cut down. We can get away with processing it a little bit before, maybe you would call it done for bag ready. And yeah, I don't want it sitting around very long. Even vac sealed and out of light and everything else, I still think we can all acknowledge that there's a shelf life. And so I think that ties kind of into some of the things that we were talking about that I was listening to, is, to do with color. What are these colors that are naturally occurring in the plant, say at the time of harvest? What are a result of aging? What are beneficial? Which of these compounds actually degrade? Because you guys talked about some aging. I did extensive aging, like on the shelf, room temperature, going on 3 years plus, where we had, like a traditional unfiltered, really unwinterized BHO, or mixed butane propane, I should clarify, and then we had like heavily remediated to the point where the actual extraction was clear, to a few different things in between that. Kind of like wax plug. I'm sure when you're doing some of your guys R&D, you guys, I'm sure, went through and seen all kinds of results and textures and different things, and so yeah, we had similar sorts of experiences, and what we did is aged all that stuff. And so what perspective it gave me was, perhaps color might be an indicator of some of these other things, like what happens to these terpenes as they degrade.
So what were your findings? Like, can you go into more detail about your experiences
Yeah, so I found that, like, yeah, any like hash in general, or any more unrefined, I'm going to call it, compound, and I will define that by something that is removed and purified. Some of these compounds that I think we're all talking about right now tended to degrade faster. So this was rosin, this was hash, this was, like we're talking, I had 60 different samples sit there. And ones that had purification to them, I'm not saying are better or worse, I'm not talking about that, but generally over long time periods tended to resemble more like what they originally were. Kind of like what RJ said. Hey, look, this jar that's 5 years old, I don't know how he stored it or what he's done with it, but he's going, it kind of smelt like that. So with the extraction types that we do now, and I think this again kind of ties back into what I was trying to say, or kind of tie this whole color and some of this conversation to me is about longevity. Whether you're a patient making your summers grow into product to fucking last you for the whole year, or this is something that's going to sit on a shelf or whatever. You know, if I can identify things to remove that are or to avoid extracting to begin with, that are going to lead to a longer enjoyment of that product, you know, then that kind of tied into what like my perspective was. It wasn't always just about color specifically or the lack thereof. And I think I've talked with Rick about this. I think acetacidic acid or whatever probably isn't the right compound, Rick, but and I think somebody else mentioned the term rancidity. You know, I think eventually, yeah, some of the either the extraction material or the extract itself, in whatever method it's done by, you know, starts to go through this process. And so my perspective is, how can I avoid that? You know, and does trying to prolong that affect the initial characteristics? You know, so it's like, can we give it some extra longevity and reduce the risk of degradation over time by the client who just leaves his jar open sitting on the table, or happens to leave it sitting in sunlight that afternoon, or whether your buddy does to your main stash that night and you're too big to notice, or whatever it is. You know, you know, to kind of go back to what Alex was saying, what are these keratins specifically, say, or some of these other alcohols, esters, whatever? Are they beneficial? Do they contribute to the flavor? Do they contribute to the entourage effect, which on our previous show I kind of told you I don't believe in, and as far as my understanding, there really isn't any real scientific evidence, let alone to show that any of these pigments are related in that process whatsoever. So, and then yeah, what are these colors from the result of just oxidization? You know, those clear terpenes that Rick has on his desk, if he leaves the cap off, they're going to go yellow. They're going to go kind of more not quite orange, but darker yellows into orange and brown. And you know, for me, I think that, yeah, if you took that cap a year from now and smelled it, it's not going to be the same compound as it was at the start of that process. And so as an extraction maker, whether we're talking solvent or solventless, like I'm not using that perspective right now. I think it's everyone's probably objective to make something that represents the plant, right? And we want to be able to have that representation of the plant last as long as possible and give the best medical value, you know.
Absolutely. What I want to do now is I want to switch it to, you know, either Chevy or Bird or you know, whoever would like to jump in on the other side of that coin. Chevy, I saw you on mute. Please go ahead.
So my question would be, is degradation a bad thing? Because again, we'll go back to the wine argument. It starts at a color and it degrades as it reaches the desired aspect of what you consider nicely aged wine, whether that's being few years, many years, 10 years, or however you want to do it. So if, on a hash matter, comparing just hash, there would be degradation, but that's half of the answer. The other half is, how does it taste? What are the effects you're getting out of it? Before ruling, is that degradation a good or a bad thing for that particular product? Because one of the reasons some hashes might not hold up well, one of the reasons would be that it has not been pressed properly and enough to create that amalgamation where that chemical changes, that some of it might be degradation happening within the hash. So yeah, my question is, do you think degradation is always a negative thing?
I do think that degradation is in general a bad thing, but I think that it's going to be hard to figure that out from an impure mixture like hash. If you take, the BHO guys can maybe attest to this. If you take extremely pure THCA, so no contamination that we can really identify, you like recrystallize it 5 or 10 times so that the solvent is clean when you're doing this. If you take that rock and you melt it down, it will look like ketchup after a couple of hours sitting in oxygen. Where the oil itself, even if you get it as pure as possible, and especially when you get it very pure, once it's been decarbed and it's been exposed to oxygen, it will turn a pink color. And nobody, as far as I know, really knows what that is. People say it's the quinone of THC, but it doesn't. It's not 100% consistent that it would be a quinone that's there. Or I'm at least not satisfied that someone has actually taken their oil and shown that they can. I've never seen somebody scrape off that red line and test it. So, here's my THC quinone. So I think that there is a certain element of just totally unknown color degradation that's happening that just nobody has really got a good handle on at the moment. At least in my opinion, I haven't found someone who can control it or prevent it. And I think that that's definitely something to work on.
Rick, do you want to jump in?
Yeah, I think it's very difficult to put a blanket statement to say that degradation is bad when it comes to aging. Like, I've got a whole bunch of aged temple balls here that they get softer, they taste better. I don't know if it's hashishine. I don't know what it is. And also the fact that, if I had 5 different cultivars I just washed, put them into temple balls, for example, they're all going to age or degrade or whatever differently. Whether it's from the terpene profile, the flavonoids, whatever else that we're not sure. Higher myrcene ones are generally then are supposed to have more hashishine. We just got hashishine in, so we I think about a week away, and we'll have that added to our terpene method, so that I can actually take some of these old. I got a couple 2-year-old. October 19th, 20 temple ball from Frenchy Cannoli, part of that aging study we did. So, I want to see if, is there hashishine? What changed, right? So I think it's just difficult to put a blanket statement. Every cultivar is different, and it's tough.
I wanted to see if I could share a picture with you guys. 710, doctor, could you share that picture of the layered extract in a jar? So basically here, what I'm doing is back to what you guys were saying, is how can we increase the shelf life of this product? I've noticed the pigment is pretty fat soluble, so it always hangs out in the delta 9 layer. So right now when he puts the picture up, that one right there, so I took a BHO extract, super saturated, and I froze it in dry ice. After testing those fractions, the top was all my terpenes. That middle layer was all the THCA. So you notice all the THCA has no color. The terpenes are also pretty fresh. All the bottom was the delta 9 layer, the stuff that had decarbed. And that's actually where all the pro-oxidants were in, So as the stuff starts to break down, it becomes like a cancer, it starts to oxidize more and more and more. So it's a snowball effect. So when I take really fresh stuff and I do this to it, yeah. So when I take this stuff and I do really fresh and I do the same thing to it, it'll just crash out all white, So that tells me that darker portion that's holding the colors really where all the oxidants are in. So if we were to remove that and then go into aging the extract, it would actually age a lot different because it doesn't have those pro-oxidants in there speeding up that oxidation rate. Another thing I've seen guys with rosin do is they'll centrifuge it to get that white portion to get to the bottom and push all the terps to the top. So then they can remove those terps and age that rosin, THCA part and the terpenes basically. That way it doesn't oxidize so heavily as it's aging and curing.
Interesting. Rosin Bell, I wanted to go back to what we were talking about before, I know you had something to add on the aged resin front.
Yeah, when it comes to aggregation, I think it matters on the method. Like with hashish, I don't think that aging process a degradation per se. I don't think wine degrades, would we? But I think when it comes to something like rosin that sits out in its edges, I think that there is a deg happen that have rosin, and it do with a lack of plant material. I'm not too sure on that, but it. I don't think every extract is the same way.
Bird, I'd love to get your take on this. You know, you yeah, I'll just let you go.
Yeah, so my take's kind of similar to what I think Rosenberg was saying. I don't feel like rosin ages, nor rosin can age. Rosin degrades. I'm a big rosin guy, very, very much so, love it. But feel like rosin, as it is exposed to elements, it degrades. It doesn't have the matrix, the cell, the part around it that you filtered out when you make the rosin. You press rosin in rosin bags, and you filter that out, and you filter out the whole cell and the whole matrix and the whole component that's around the resin, and you remove the resin. And in a sense, in my mind, I like to refer to it as you make grape juice when you make rosin, and when you make hash, you've made wine. And wine can age, and grape juice doesn't age. Grape juice degrades, and it doesn't get better with time because of the matrix that is involved with the fermentation process needing to be in that whole mass to create that fermentation process and aging process to happen. So without that, you're just getting those factors to cause it to degrade.
Kind of, where are you at with that? Like, is that something where, you know, that makes you can align with, or is there a disconnect there where your experience leads you to think otherwise?
Yeah, I mean, I think in some reasonable thought that the cell wall, that cellulose like layer of the trichrome head itself is acting as this antioxidant layer. It's preventing you know, just the environment from getting at it. But I think the analogy of wine and juice and stuff is not kind of off. Like if you'd leave wine on the counter, it degrades, right? If they didn't put sulfites in it, it would turn into vinegar fairly quickly. And so my thoughts are the same with hash or BHO or any of them. Is not, my perspective isn't just to BHO. I really want to make that clear. If yes, if you know, we had a method of storing hash really well and keeping it away like a barrel of wine would be, right? And then you break it open. Well, to me, that's the same as opening a bottle of wine, right? You've started the degradation, like you've started the end of that. The same as any jar of concentrate, right? If you open it and you're into it, it is what it is at that point. Yeah, you can put it back in the fridge and try to prevent that thing from degrading further. But so yeah, I think the cell around it can definitely help that. But I think when Chevy's talking about the process, like they're talking about squishing and heating and amalgamating. So I'm not sure that cell is part of that process. And I think if we actually talk about what goes rancid, it would be these fats, it would be these waxes, it would be some of these other compounds that myself personally I'm trying to remove to begin with, because when we actually start to look at the like what is dabbing wax, it's not gonna, to me it's not beneficial. It's not adding to the flavor. It's not adding to this quote unquote entourage effect, you know. I don't think it's adding to shelf life or helping that. So, but I can totally get my head around the idea that some people would maybe prefer something that's got a more fermented-esque thing, a different character, a different depth of flavor.
Yeah, absolutely.
For me,
sorry, go
I've
ahead.
talked with Rick about this. Like, I'm not a huge, like, I didn't grow up smoking a lot of hash. I have an appreciation for it. I have an appreciation for rosin. I have appreciation for BHO, but I don't have this nostalgic thing that kind of like pulls me really in either direction. Right? I grew up smoking a lot of flower. But yeah, whether we're talking flower, BH, or whatever, generally speaking, I don't think age helps the equation. That's kind of where I'm at with it.
Chevy, I saw your mic unmute there, and I'd like to sort of ask you: do you feel you're in line with those statements, and so far as that it's at the point now where it's just a personal preference of a flavor profile, or do you think that there's much more to it than that?
So on a North American standards, Tim is absolutely correct, because that's currently where the concentrate world is heading. Not necessarily for everything white and clear and whatnot, but the whole premise of refinement. While the rest of the world, when they think of cannabis, it's mainly hash. So when it comes into the aging part, yes, the fat might degrade, but it would degrade if it does not get that proper heat treatment, and if the whole mass of hash pressed together did not have that sticky layer of resin. Basically, hash is being aged and encapsulated in a very thin film of resin oil, not just the fats, and it encapsulates the whole thing. The chemical process that happen within usually goes against or reduces the spoilage part Tim is referring to. And even after cracking a hash that was aging for a while, using cellophane or reforming that resin ball where you let the resin ooze out again, this is how you would usually maintain hash. And as Frenchie has quoted in his travels, he have tried hash as 5, 10, up to 20 years in Nepal, but that was a charas style, still hash. They have different terpene composition because charas is basically made from live heads. But going back to the idea, the piece of hash is always in a good condition and safe if it's away from direct sunlight and fluctuating temperatures, and not being rolled properly and pressed enough where you would have that sheen layer.
Absolutely. So let's move it over. I want to ask Tom. Tom, you've been pretty quiet and just listening. Do you? What are your
and
thoughts?
then hold on, and then
Sorry, go ahead.
I was gonna say I can see Bird stirring because he's kind of like a Frenchie descendant. So we got to circle back because I see Bird. He's keeping it quiet and everything, and I want to hear, because if we can't have Frenchie here to talk about the science behind that, I think Bird is maybe one of the next best things.
Well, I appreciate that, and yeah, I could feel Frenchie in me, kind of losing it a little. Yeah, I mean, rosin, of course, is going to degrade it, of course, exposed to the elements, and I feel like the elements are really the factor. Your rosin can be preserved correctly and not degrade, but it's not going to gain a terpene profile, is how I feel, and how I've been taught by Frenchie was the terpene profile when you do the aging process can acquire a terpene that was not found in the flower nor in the loose resin when it was tested. Now, when you age something, you have, like I said, that matrix that is involved in that. When you make rosin, you eliminate that matrix, and by doing that, you're going to allow something to be amazing and good, and you can preserve that, but you can't make it develop a new terpene and acquire what hashish can acquire. Is kind of how I feel.
Rosenbell, I know you raised your hand. You wanted to say something. Please jump in.
Yeah, I was gonna say the thing that comes around the hashish is protective layer. It allows to I don't know if you would want to call it fermenting, but to continue to transform side protected side own, and create these beans that you pull up in aged hashish weren't before it was rolled.
So interesting. I think that's really interesting. RJ, I want to ask you. You work with a lot of large amounts of material, and you have access to more material than the average person sees. What are your experiences with these matters as far as aging goes, and your opinions on the topic so far?
So I kind of get the other side of the coin for what Mr. Kind Selections is talking about here. I see a lot of material that is of different age, gaps, and we also process for different customers. So I kind of get what I get, and I have to work magic with it. So I kind of have to change my philosophy on the way that I approach my filtration. So at first, in the pursuit of color, because I didn't understand selective filtration as much as I've kind of developed that knowledge now, thanks to guys like Waxplug, and like putting that knowledge out there, hitting the forums hard. So definitely appreciate you on that, sir. Definitely made that knowledge a bit more accessible for guys like myself. But I approached it with the thought that I would kind of, not to liken it to distillate, but I wanted to keep the heads and the main body fraction and get rid of the tails, because the tails are going to be the things that are the most oxidative, the most would cause that kind of rancidity, like we've been talking about, would cause that kind of adverse flavor that we don't want either at the point of extraction or on the shelf over time. So CRC has allowed us to remove that. So talking about shelf stability, now we have a more consistent flavor profile over time. Yes, it does change. You know what I mean? That's the nature of the beast. But it's more palatable for a much longer period of time, with that said. And now with more selective filtration and being able to target certain things, I think we're just going to be able to create a more, we're filtering stuff here, so it can't be a full spectrum extract, right? But it's still, a broad spectrum, but it's going to be a more shelf stable, more palatable, more customer friendly product for longer. And I think that is a good thing for everyone. You know what I mean? There is definitely some guys that don't understand the media that we're working with, and get filter bypassed, media bypass, and you hear all these nightmare stories of media silica in the resin, and it's awful. You know what I mean? The knowledge is out there. People just got to educate themselves. But this is also the nature of the beast. There is good hash, there's bad hash, there's good extractors, there's less knowledgeable extractors. You know what I mean? There's people out here that are just trying to slap powders around, and then there's dudes out here that are trying to actually make a quality product. So
I did want to add on to what Bird was saying. I completely agree, and I don't know what it is. When you look at testing, and we're getting like 90 to 97, 98% cannabinoids and terpenes on, some of the best extracts around. What there's not much left in there. And then you look at some of these like amazing temple balls that are, say, 55%, 60% total cannabinoids, 5% total terpenes. So not really sure what else is left in it. We know that, rosin's impressed or BHO extracted and all that kind of stuff, and whatever other kind of remediation that can happen with it, but not really sure what we're losing there. What's, as Bird mentioned, what is in these temple balls that's kind of helping it age, because I definitely do believe that this ages like a fine wine, and not just kind of not sure what it is, whether it's certain flavonoids, the anthocyanins, all that kind of stuff, right? It's open, right? I want to kind of figure out more what that is. And hashishine too, by the way.
Absolutely, and I want to touch on that with Adam in a little bit. But first, I want to hear a little bit from Alex about you're doing some really interesting stuff with being able to track these pigments. And I mean, I think we've identified in this conversation that these pigments aren't just colors; they have a major influence on how we're perceiving these extracts. So I'd love to hear more about the project that you're working on. Oh, you're muted. You just got to hit that mute button.
Sure. Thank you for letting me talk about it a little bit.
No worries.
So basically what we have is we built a sensor to try to get ourselves a little bit, to have a little bit more of a consistent view of what kind of pigments that we're dealing with. And basically the way that the sensor works is it takes the idea that George put out there earlier in the presentation or earlier in the talk about using a UV light to excite the pigments inside of the powders. So basically using the properties of the pigments themselves, we shine a UV light on them and use a light detector to see what kind of light spectrum is being generated by that sample. If you go to the next slide or one of the other photos. So here's a photo right here of what the kind of spectrum looks like coming off of the sensor. On the far left, you have the excitation light, which is a UV light. And then to the right of that, you have lower energy light in the blue, green, and yellow spectrum. And basically what this light is it's the light generated by carotenoids when they're excited by UV light. And it's really kind of low-hanging fruit, and it's kind of lucky that they do this. Nature kind of designed them as in a way that allows them to take in energy and then pass on that energy. When they're in a plant, they're usually passing it on to a photocell for photosynthesis. But when they are removed from those cells, they are still able to pass on to absorb light and then pass that light onto other things. And so they end up releasing photons of light that are lower energy, and we're able to detect them here. So the carotenoids, which are red to our eyes, will glow blue, and the chlorophyll, which is green under visible light, will glow red. And basically, you might think that you can differentiate pretty well with your eyes, but it's actually very hard to tell the difference between a sample that has all blue light and then all blue light and just a little bit of red light in it. And the idea is we use the sensor to see down to very sensitive levels of chlorophyll and also carotenoids. But in general, carotenoids are acceptable in our industry, and chlorophyll is the one that we want to avoid to a degree. So the sensor basically just gives you a way to have a 2D readout or like a JPEG image readout of what your spectrum is, and then you can save that for future use. If you go to the next slide, so this is what the program looks like. It's basically just a USB attached to or USB connected to a computer or USB-A, and then fire up the program, and you've got a way to test your extracts for their pigment concentrations. It's not quantitative; it's a very qualitative thing, but it is, it's a technology that has been used to quantify things like chlorophyll and things like carotenoids in other industries.
Qualitative, how so?
It's qualitative in the sense that, like, you look at it and it will give you a two-dimensional spectrum, but it's not going to tell you a milligram per gram of a certain compound. You have to take into account the fact that, you did a dilution. Usually you'll take a sample, like say you want to see what kind of pigment is in a small sample of extract. You'll take a sample of it about 0.2 grams and dilute it into solvent and then put it into the tracker. If it's a more pigmented extract, you have to use more of it. And so it's not something that's going to necessarily give you a quantitative number, but you can kind of be quantitative with it if you keep good notes and you record what all the concentrations are. going in. But it's not even really necessary to be quantitative. If you see some red light on the sensor, then you know you have some chlorophyll there. And if your goal is to remove all the chlorophyll, then you can do that. The relative height, if you go back one slide, if you take into account the concentration of the sample and then the relative height of these peaks, you can kind of get an idea for how much of the chlorophyll you need to remove. You know, if you imagine that the chlorophyll was half the height of the peak, it's going to have less chlorophyll in the sample. But there are limitations, because that's actually not necessarily always true. It could be that the chlorophyll is just degraded, and there are still, you know, chlorophyll breakdown products that are not fluorescing that are still in the sample. But again, it's kind of a qualitative indicator where you can use it to tell that you have some contamination, and then you do something to your extract and then use it again to see that you've removed that contamination. And so, like, if you were to carbon filter this extract, you'd want to see afterwards, or let's do silica, which is going to remove the polar compounds. Chlorophyll is not polar, but it's more polar than THC. So we look for this compound to be removed, and for us to have a high yield of material coming through with mostly just this light being generated under UV.
Does it work on all concentrates and extracts?
Yeah, it works. Anything that's a clear sample that's been diluted and is clear. So, like, if you take a hash sample and you put it into heptane or let's say into ethanol, it's going to be cloudy, and so that will distort the image. You have to actually filter the liquid using like a syringe filter. It's not too much of a sample prep compared to the type of stuff that Rick is dealing with, with, you know, all kinds of matrices and like and different, you know, big expensive instruments. This is really just to dissolve it and get it clear, put it in the instrument, and then you can get a quick spectrum for what you're looking at. And this was how we figured out that when we were doing some ice water extractions, we were getting chloroplast. We were not getting chlorophyll, because we were able to take water that fluoresced with this red light, and we were able to filter over just a particle remover, and we were able to completely remove all of the red light from the water, which means that they were particles suspended in the water, and it was not, and it wasn't dissolved chlorophyll. And to the human eye, it just looked like two samples of normal water, but one of them was glowing red and one of them wasn't. So that's kind of the use on the ice water hash side, is just to look out for chloroplasts and to make sure you don't have too much contamination. Usually ice water hash is way lower pigment than butane extraction, because these are fat soluble compounds. And like you said earlier, you have to bathe the entire plant in that solvent. So there's a much higher likelihood of getting these contaminants. I would guess that poorly made ice water hash could have a lot of contamination too. But we actually saw, when we were using this, really remarkable consistency between the micron sizes of the bags, where the lab washed the same material 4 different times and collected 3 different micron sizes, like a 220. I'm not an ice hash extractor, so I can't remember what exactly the microns were, but they collected 3 different ones, and on all of the washes, the bags looked similar across the washes for the same micron. So the 220 in the first wash looked the exact same, had the same ratio of pigment concentrations as the first wash, or as the 220 micron on the second wash and the third wash and the fourth wash. And the other bags had a different balance of pigment. It was consistent across all of them, where these peaks were significantly similar, which was cool to see. I don't know exactly what that means, but it did have, it definitely has an application for ice water extraction, as well as the butane extracts, which it's really hard to avoid chlorophyll with butane extraction, for sure. So anyways, that's what it is. It's a pigment tracker.
Very cool, man.
Yeah, could you see different pigments in the first, second, third wash when you were checking that out?
So
levels, or?
Yeah, it was different. No. So it was actually very similar pigment levels. Yeah.
Okay.
And I think that was because the yield was decreasing, and partially the pigments are just, or the pigment is like, it's chloroplast being caught in the yield of. It's almost like it's an absorbent bed of trichomes, where you've got just like if you imagine piling up a whole bunch of trichomes and then you pour chloroplast on top of it, the chloroplast isn't just going to pass through it. There's some physical barrier there that's preventing the chloroplast from actually exiting the bag. I think that's why. I think it was the mechanical, how much is being held back by the bag itself is the thing that determines how much of that contamination is there. And they had a really tight system for their extraction down, where they seemed to have a really good, like even on the fourth extraction, it was blonde coming out of the system. It was just less of it.
Well, I'll have green water, but then have beautiful blonde hash because you sprayed really clean water through.
Yeah. So the first water that comes off is usually, it's going to be like there is a water soluble yellow pigment that can be rinsed off of the hash. When we did that experiment filtering out the chlorophyll, and we're able to see that it was particles of chlorophyll, the yellow pigment was not removed. So the yellow pigment made it all the way through. And that's good and bad. I mean, it's good because you can just wash the trichomes with water until they stop giving off that color. I mean, it's just bad because it will get caught in the water, so you have to deal with it. But it's that was some interesting stuff. And just overall, though, you can the amount of pigment in the ice water hash that's made well was way lower than the butane hash that's made well, for sure.
Interesting.
Except, honestly, guys, George is a little bit of an exception. We tested his stuff, and his stuff had almost no chlorophyll in it. They were using propane, which maybe is something to know. But I've tested plenty of propane extracts that have a lot of chlorophyll too, so it could be.
George, why do you think that is?
I think because of how cold it was, and
your mic's going out.
Love to hear you.
I don't know, to be honest. I mean, I know we filtered one of the runs. I don't know if that's the one you checked. If it was the one that got filtered, then that would make sense. But if it was the one that wasn't filtered, it would be
It might have been that you guys had a CRC going on that.
We did two runs that day. We did one that was filtered and one that wasn't. The one that wasn't came out more orange. The one that got filtered came out more brown. And what that meant was that the adsorbents had took the carotenoids, the oranges, and the chlorophyll out. So that's why we ended up with the more brown in the filtered extract as opposed to the not filtered that had a lot more orange in it. But
yeah, I mean, one of the limitations to this technology is that it doesn't give you there's a billion, but there's a long list of things that will look the exact same on this sensor as carotenoids. It's just blue light. It's literally, if anything that shines blue when you shine a UV light on it could be tricked into thinking it looks like it on it. So that's definitely one of the limitations. But I mean, at some point we just have to go, we're extracting grass, and there's a certain number of compounds that we would expect there to be, and we just have to go after the most obvious ones at some point, and assume that they are non-degrading, and they are that there is a use case of just growing weed perfectly and undegraded, and then extracting it and dealing with just plant compounds that are there. And I think the carotenoids, xanthophylls, and chlorophylls are for propane extraction and butane extraction are for sure the most important ones, and also for ice hash.
Yeah.
But
Sure, go ahead.
No, I was gonna say, but this isn't the end all, the answer for sure. This is a quick test for us in the lab. If Rick, if you can start offering cannabis carotenoids and chlorophyll testing, it would be epic. Just because to have people who are experienced with the matrix being able to do those tests would be really. And I don't think we would even need to do that many. I doubt that it's that variable between plants. Probably a couple dozen tests, and we can get a pretty good idea of what the compounds are. So that would be really exciting to be able to send you samples and to be able to send you like isolated samples. So like this is a better one. This is better. These are like an isolated carotenoids fraction.
Wow.
See how? I wonder if I can get some people.
Wow.
That's super red.
Yeah, it's like a mix of carrot and tomato juice there.
So that's I wish I put it right, but basically like one drop of this stuff and like a jar of distillate can turn. You can start to see it. Maybe not one drop, but it's a very, very small amount that you need, and it can end up causing. It smells like carrots. I swear to God, it smells like carrots. But basically, this was just isolated from a non-polar, from a propane extract, and I could send you this. I mean, it's old, and so maybe it's transforming in the jar a little bit, but we can test samples that have also been isolated, so you don't have to deal with the cannabis matrix. I'm looking for like a trace 0.1% compound.
Yeah, no, I would definitely be interested in that. That seems really cool. I haven't done much research on those flavonoids. Definitely done a bunch. Hashishene. I know someone is commenting about UVA and UVB, and some of the research I did on hashishene as we were trying to find someone to make that standard for us. They meant, or some research out there was showing that it seemed to be higher in the traditional Middle Eastern hash, and they think it's had something to do with the sunlight. Like apparently some of them are taking the flower, drying it like on the roofs and stuff like that, or just a lot more sunlight exposure. And they were saying that is part of the key of myrcene converting to hashishene, and why there's a certain taste for that kind of hash.
Yeah, we
So if of hash fruit, like the that was expelled earlier, there's the carotenoid more red in the sunlight. Is that what would be hash than orange? The more it's bringing nutrients, I suppose, or transforming.
I think that the sunlight idea and causing it to darken is a really good one, because sunlight has very high energy light that we don't see. And if you dry a plant indoors under fluorescent lights or under just normal light, it might be different than drying it outside where there's sunlight that's got a ton of UV. We've taken samples of water clear distillate that's totally fresh out of a still, so it doesn't have any other oxidation, and aimed our 10-watt flashlights, UV flashlights at it, and it'll turn purple, like a deep purple kind of color, and not on the top, as like throughout the sample it will turn purple. So I don't know, my point being that THC obviously has some kind of effect where that happens. I would imagine that all of these compounds, there's a layer of, like, if we did all of our processing in the dark, would it be different? And we could probably look at a lot of these compounds and see how the UV light is affecting them for sure. And it could even be like UVC or UVA or UVB, like UVC light that's used for like sterilization is way higher energy light than what we're dealing with here. So what happens to Delta 9 when you aim that at it for a period of time? Maybe it turns red. We could probably make a lot of different colors.
What have your experiences been with this?
You say Brian? Or
oh no, I think Kind has had some experience using fluorescence as well, and I'd love to hear his experiences.
Yeah, I've seen the purple, just not even applying UV light, just having Delta 9 at high temperature with sudden exposures to oxygen, atmosphere, and just like, I've seen it come off.
It's
beautiful colors of purple.
We think it's like a similar kind of purple, but it happens kind of like homogenously through like where you aim the UV light at, instead of being kind of at the oxygen interface. And maybe I just need to go and look to see in the literature, is there anything obvious that's UV? Maybe it is the quinone. that we're talking about, and then it would be I think it would be useful to look for that in the hash samples as well, because like with pure samples, when we're dealing with like super pure distillate or super pure like THCA, if you look at it wrong, it changes colors. And it sounds like the hash, there's some indicators of quality that are based on the colors. So maybe that, that's what we need, is to come together both sides of it for sure. I'm not aware of when hash changes color at all, just when distillate and THCA does, mostly.
Rosenbell, did you want to jump in quick?
Yeah, so coming how do we describe degradation then if it's not by color, because we know then that some change the color, but we don't consider it degrade. And indoor doesn't change from it's as an amber is quicker good indication then.
Absolutely. Sorry, I might not have caught all that, but I wanted to ask Adam. You just got back from judging the Masters of Rosin, and you were specifically I believe, looking at mostly melt all weekend. Were you correlating color with quality? Can you talk a little bit about that judging process that you undertook?
What'd you say? Mostly melt all weekend?
Were you judging rosin, or were you judging? Was it rosin or was it melt that you were judging?
No, it was all rosin, and one person
rosin.
entered, who's still anonymous to me, entered a pressed Moroccan hash,
Yeah,
which had like a nice hazy sort of smell to it, but it wasn't rosin, so kind of had to judge it lower compared to the rosin. But yeah, no. So we were definitely, I definitely judged rosin, and we graded it first by just looking at it, or at least I did. And categorized just literally the appearance. So I I put the shades all together, the different shades. I put the crumbles with the crumbles, and the textures with all the different textures, and the fresh press together. And then I went to smelling everything. So first I just judged the appearance, and then the smell. But so I don't know. That has to do with pigment, right? The appearance.
no, absolutely. And were you able to make any correlations between what was appearing, the lightest, was that commonly correlating with the highest quality that was ending up in your books?
I wouldn't just say lightest, but most appealing overall, almost plasma like clean, and then also clean on the dabber. So I guess I should just explain the different categories that we judged. We did, or that we rated. And I did a 0.5 to 5 scale rating. And it was appearance, smell, taste, and then the after dab. And so, like, after you dab it, what, like, all the kind of a nuance of different things, like how dirty did it look on the nail? Maybe was there a blowout? So obviously you rate that differently than not. And then just various other things like does the flavor truly translate, or did it hurt your throat, or all this other things that kind of that's the after dab, or at least that's how that we judged this event. And I thought that was kind of cool. A new that was a new rating for this 2022's Masters. But yeah, I kind of went off there. Forgot about what.
No. That's really cool, man. I know you've kind of been traveling and you're a little bit jet lagged. I think the last thing I want for you to touch on is something that you touched on briefly already, but your views on amber trichomes and them actually just being refractions through to the I believe is it the disc cell, or is that the disc cell of the gland?
Yeah, so the disc cells are what those they even call them a matrix of cells that sometimes look concave, but they're at the bottom of the gland head. And then there's stipe cells, basal cells, but those are a part of the elongated dermal cells of the stalk, mostly. And the stipe cells, sometimes those will break off and have chlorophyll and stuff, but usually the disc cells, from what I've seen, are what you see turn amber. I have some pictures. I didn't realize that we would talk about this, or else I would have sent them. But you can literally just see the amber is the disc cells, and they're just degenerating. And I don't mean degenerating in a bad way. I just mean I feel like there's a certain ratio of gland heads that should be of those disc cells to be degenerated, and that means that they're in their into their life cycle and they're about to burst open. They're ready for like an animal to walk by and rub against them and spread their whatever they've been stored, whatever is stored inside of them. And so I think that gland heads and contiguous gland heads should be, in other words, there's a percentage of these amber, kind of like people say you want to pick it when there's a certain amber percentage. Well, that's not exactly true. I think that there's a Goldilocks zone of a certain amount of amber, and that also is determined by what kind of plant it is. So what kind of flowering time, like if it's a shorter flowering time and it's degenerating faster, you might want to chop it before it's really turning super amber. You might want to chop it when it's around 10. But if it's a long flowering, thinner variety leaf, there might be you can go more amber with it. But with amber, I don't mean anything bad by it, and I feel like we kind of put certain terms on these things and think certain ways on it. But really, it's a fucking crazy amount of shit going on inside that gland head. The disc cells are definitely where those proteins and everything is going. It's secreting these vesicles, and that is the oil. You can think of it as the oil inside the gland head, and that definitely is a cellular structure that cellularly degenerates with time.
Absolutely.
And
Tom,
then that refracts light.
Tom, do you agree with what Adam's saying? Is that what your experience is as a cultivator and a hash maker?
Yeah, definitely. I mean, I don't want it ever to go. Well, sometimes I like to go deeper into the amber for the effects, but I usually don't go too deep into it. Maybe like a 5 to 10% sitting on there, and then I want to pull.
Bird, I know you're pressed for time. Do you have anything you want to add?
Yeah. I hear you guys really talking about how you determine on when you harvest according to the amberness of a trichome. And I just wanted to touch on the fact that trichome is the secondary metabolism to a plant, to the cannabis plant, and that really has nothing to do with harvest, or does it not correlate to harvest time. The flower itself, it would be like looking at the trichome of a fruit to determine on when it was done, and you don't do that. You look at the fruit to tell you when the fruit is done. Now the fruit will tell you when the trichome is at its most robust time to harvest. Now amber can be controlled by many different things. Can be light, like we said, your outdoor trichomes are going to be more amber, so you don't want to pick according to your amberness of a trichome, nor look at that according to when and give you an association of when to harvest. Because like I said, the secondary metabolism is never anything you're supposed to look at, nor do we look at when we're growing any other vegetable or fruit that has a trichome. We don't look at the trichome for when to harvest our fruit or vegetable. It's according to when the actual product is produce is ready.
So I do look at the whole flower, and I use that as a reference before I look at the trichomes. But my final goal is to isolate those trichomes. So that's what I'm really focusing on. Now I'm looking at the flower, but I'm really focusing in on that trichome at the end.
Also, the ripeness of the floral cluster is associated with the ripeness of the trichomes. Is something I believe too. So that's true.
Rosenbell, were you trying to jump in there? I know you've got some experience cultivating as well.
I mentioned also the neck of the trichome as well as an indication of trichome. So the thinner that it gets, like a fruit tree. If you shake a tree, the ripest fruit fall off first, and it's very similar with trichomes. The ripest ones will snap the fastest.
Yeah, I would agree with her on that one a lot. That's where I tell people to look at is not at the amberness of a trichome. Look at the abscission, where the trichome stem is cutting in on the trichome head and creating that abscission to come in and allow, like she said, for, like Rosenbell said, for the fruit to fall off when it's most ripened. That would be a better indication of what you would want to scope, is that abscission on the trichome, not the amberness of the trichome necessarily, because you could have that abscission happening according to any one of those variables, and then that would be your guide to when the resin is fully developed inside that trichome.
Adam, what are your thoughts on this as somebody who's studied trichome structure?
Well, I agree, but I don't think that you should solely go off of the amber look, because there's such a dynamic amount. There's a diverse, cannabis is so diverse in its shades and hues of colors, you know. So when we say amber,
where you're seeing the actual neck of the trichome slightly come in and get ready to for the gland to break away.
No, I agree that there's that abscission portion.
Yeah.
They even, you know, there's some plant journals that I've read that they literally refer to it as an abscission, where the gland head breaks off of the stalk. And Frenchie has referred to a lot of that science too. There's some older science I wanted to touch on earlier from the 70s, and they caught some people smuggling pressed hash. And so they studied that hash, but they also prepared dry sift in their labs in the 70s. They had dry floral clusters, and they ground them up, and they like quickly tried to sieve, and they got gland heads, you know, and then contaminants and stuff in stocks, but different, you know, levels of quality, but also just a sift that wasn't pressed, right? So they were studying how, I mean, the whole thing was exposing these different kinds of hash to temperatures and different lights and different storage containers, I believe. I'd have to go back and check it out, and I can try to link you guys in it, but I just thought it was interesting. You know, it does, you know, when you press it, it does make a skin around it, and the THC is stored inside that, and the skin doesn't have much THC at all, if any, but inside it's being stored.
And what is the skin?
Slightly pressed sift stores a little bit better than sift that's just obviously open to the air, right? Yeah. So there was all this different things that were going on with it, but just wanted to touch on that for a little bit. Thought it was cool.
Yeah, and on that same subject too, when we were talking about the abscission created and how important that is there's the underneath part of the trichome head where that abscission is has to develop a membrane that is what they would consider to be waterproof. Water does actually can transfer in and out of a trichome, but it's still considered waterproof, kind of like your mouth or something when you closed it and jumped into a pool, you know what I mean? It would still be waterproof, but you could still shoot water through it. Now that part has to develop, and it's not there the whole time, just ready to go and developed until that abscission has happened. Now, if you don't watch that and wait for that to happen, and you're going by other factors, and you don't use that as your factor, you could remove trichome heads. Now, this won't be as big of a deal if you're using a solvent, because you'll still be able to wash the whole material. You're not really worried about removing the head. Now, but what we're doing is washing. We need to remove that head off very, very gently. Now, if it doesn't want to come off and it tears off, or it tears some of that stem off, it's not going to be waterproof. And if we're going to wash it in our bags, and we're going to actually lose that trichome. So it's very important that we go for that abscission as our biggest factor for washing, because of multiple factors, not just for that, the fact that we need that waterproofness, but for the other factors, for the resin that's going to develop inside that head. it's just a very big factor that I like to try to put in people's heads and think about, because it's something that is not really thought about in the solvent-based community, because they're not really even worried about that.
No, huge facts that you just dropped here, Brett. Like,
Can you
that
put
you
up
just
that video?
changed.
Yeah.
You just changed how we should be looking at harvesting. Fuck the color of the heads. Don't worry about your leaves. Yes, take out your microscope, but you're focusing on the wrong part. It's like, bro, you're looking at the asshole. You're not looking at you're not like, yeah. It's, I don't know. It's a completely like different way. Sorry. What did you want me to bring up?
Can you bring up Adam's video of the image of that gland? And I want to ask Bert if he thinks that's a premature gland, and that's what we're seeing is basically where Adam, you
You're
should.
talking about the one with it releasing stuff?
Yeah. I'd
No,
love to
that's
get your
just like
thoughts on this. Adam.
an awkward part of it, so much between glass. I just got that. But there's, if you were to flip it around, it can totally be darker. That's what I'm trying to say. Is like, it's that disc cell, and that's where the abscission is. There's this disc cell, and what he's saying is the abscission is this. We can't really even see the disc cell in here anymore. It's so
it's been mashed.
Just that's not. Yeah.
So
There's another image, but
you were saying that
the disc cell definitely cutinizes at a certain part of its life cycle, the trichome's life cycle, and if you read this cuticle development paper on trichomes, you learn that the disc cell is what first forms. The first thing that you see cellularly is two different cells. First one, but then it breaks into two, and cellularly starts to why can't I think of the word?
Divide.
Replicate.
Anyways, the disc cells eventually
secrete.
No, I don't know where I was. Sorry, there's something playing in the background, and I totally forgot what I was talking about. But they are what. See how at a different angle it's a totally different color.
Yeah.
And when it's clear, it.
That's an awesome picture.
It's acting as
it can be amber, but then it can be clear. It just depends on what angle you're looking at.
Right? Eric Nugshots for the win. You can see the disc cells here. You can see where like it's kind of tucking in underneath at the stalk there. And kind of amazingly, depending on how you're looking at it, you can see his light and you can see what's going on in the room reflected.
I remember what I was going to say too. So at a certain part of the life cycle, before anything's being secreted, it's the secretary phase of the trichome.
Yeah.
The disc cells cutinize, and then the disc cells start to release the vesicles, and then the vesicles can also contribute to the sheath of the trichome, and those last 2 weeks of flowering starts to exponentially grow and fill and store secondary metabolite inside of it, and it's all being secreted by those disc cells and being pharmacologically derived from them because of the proteins and other good stuff that's doing things that I can't explain.
Tom, you had something to add.
I was just going to make the connection that Adam was saying earlier, that amber comes from the disc cell, which we're also looking at the disc cell for the abscission. So in a way, they're correlated. If we're waiting for that disc cell to kind of start being able to break off, like an apple tree.
You can have trichomes that are still clear where the incision is all the way through it. So the amberness doesn't particularly have a lot to do with how trichome is, because if you get in there with a microscope, you can see different colored heads at different redness. Some of them might be completely orange and right, while some of them might be clear and still have the same incision.
Yeah, like on that picture that you just keep showing as a trichome, if you would have scanned that over a 1 millimeter, you would have saw a trichome with a different amount of amberness to it, and so then that tells you right there that that's not really what you want to use as your factor, because where are you looking at on that that part of it, because there's going to be your amber trichome like right next to that one that was like in between, like he kept showing where it wasn't at all and it had some amber to it. You look at the one right next to it, there'd be an amber one.
But you're seeing consistency in the abscission.
Exactly.
Yeah, that makes sense to me. That's very cool.
One thing too, I want to add that in that image that Brian just had up, where Frenchie suggests when to harvest for hashish production, we're actually working with his wife right now. We're going to be announcing soon a big study we're doing. We're going to have 3 different cultivars that we harvest at 4 different through 4 different times, and then testing that. And we're going to do. Then we're also making hash out of that each of those 4 times, and going to be testing in aging that for upwards of a year. So it's going to be just over 400 individual tests. So it's going to be quite a big project for us, and we're really excited to be announcing that soon. But since we're talking about it, I figured I'd bring that up. And
that's very
hopefully we get some cool data out of it.
That's really cool.
With exactly what we're talking about.
That's really cool. Really appreciate you doing that, and that means a lot to hear. And Frenchie and I would always talk about that and how important that is. Like we always talk about is like, I could tell you how close to harvest you harvested your stuff when I make temple balls with it, and I know how close it was to when that resin was developed fully, but I can't tell you before that. I can only tell you once I've made temple balls with it, and all my temple balls come out, and I can start telling you by how they're coming out, the ripeness of your trichome, not the amberness of it. And that was a factor that a lot of people look at. You know, what I like to tell people is, like some of these guys were saying too, is it's like, it's a good tool to use once you become accustomed to genetics and you grow it and you're so like in tune with cultivating that, then you might be able to use the amberness because you've grown it before, and then you know so many nuances that you're using in your head to add that as the factor of why you're being able to use the factor of you're saying like, well, I've grown this one before and its resin is fully developed when I see 10% trichome amber. You might be able to use that as somewhat of a replicating a factor and using that as a tool in your tool belt. But as long as you understand the background of it and know that that is not what your should be looking for ripeness of fruit, nor would you look at any fruit and tell when its trichome was ripe. You wouldn't look at a tomato and go, well, let me see what that trichome looks like. Or when that tomato's ready, you would not do that.
So, Bird, when you're saying that when you would make temple balls and then you could tell when it was, say premature or not, would you find that those would age differently, and also would they taste different?
Yes, dramatically. And you'll know, like the ones that were the mature ones, they will age immediately. And within 3 months, you will see a transformation that you won't see in years with the ones that were not
really that quick
harvested.
3 months.
3 months. You will see it. In 3 months, it will cause the temple ball to push oil out of the cellophane and from the temple ball, push it out of it, and to where it'll like ooze out. And that's
I thought
when
minimum
you're having
10 months to a year. Like that was my thought process.
3 months is when you see actually a terpene, the hashishin terpene he's talking about, Rick has been talking about. That terpene is developed in 3 months, and then is, like I said, been found only in aged hashish. It is not found in rosin that is sat for 3 months in its perfect climate or any climate. You don't receive.
What are you correlating with that? What do you correlate with the terps being pushed out of the temple?
So that's when the fermentation process is happening correctly, and it's building pressure, like when you would do wine or something. And all this has to be done under very controlled environments, because otherwise degradation will happen and it won't be, just like he was saying before. You can't just think you're going to store a temple ball in regular temperatures and regular environments and have that age correctly, nor would you expect a bottle of wine to do the same thing. And the secreting is the oils. It'll build pressure. Now, if you tie those up like Frenchie taught us, you tie a knot and you flip it over and you tape it. And so the twist is held down when you do it. Okay, now that's how he shows us how to do it. Now, when you do that, you'll squeeze it. When it's 3 months, it'll be filled with like gas. It'll be puffed up. And that is when it's happening, the process. Now, if you take your plant and harvest it at all mature, that process will not happen in 3 months. And if you do it all too mature, that process will never happen. And it will always be a dry temple ball. You will never have that full fermentation happening because there's so much of this matrix that needs to be there that you will lose in that process. That it's just so delicate to do. We don't. It's not really that easy to just explain. There's so many variables going on, and you have to do it right. And the ripeness of the fruit is the biggest problem, and that's the biggest factor. Like that, like I said, in 3 months you'll have a complete transformed temple ball that will be a wet, gooey ball that is like sugary wetness that is hard and has different floral profile, aroma, and taste that you can taste the developing, and it's a developed flavor that is gained a terpene. Not like some things like you take rosin and let's say you like it as it sat. Well, you like the fact that it lost a terpene. That garlic terpene it might have lost that you don't like or whatever. It didn't develop a terpene, but it lost what you didn't like. And now you like it. So you think it has gotten better, but it actually just lost the terpene that you didn't like.
Wait, so Bert, on that point, because you're stimulating a new question for me. So, do you think a plant harvested maybe a little early, maybe exactly on time, and maybe a little late, how does the rosin degrade at different levels and then produce a better quality terpene or effect the same way a temple bud? Not in the same way because it's not going to be the same, but will it have like that same difference?
No, actually, I don't see that difference because, like, I see more like a temple ball. If I make it from product that is a little bit taken early, it'll make a clean rosin that will still be good because you refine it down so much to make rosin, and it doesn't need that matrix to be able to secrete that resin that is there and refine that down and give that to you. But a temple ball needs this matrix to be there for it to actually create this aging effect, for it to do like the pressure, to be able to build that pressure in that gas. That's a lot going on inside there for it to have just done. And so I don't know, I don't see that at all with rosin because, like I said, it'll just be in it'll be actually a little lighter color and it'll just have a little bit less flavor. You know what I mean? Because terpenes are the color in the sense this like we've been talking about, and so if it's premature, your rosin will look a little bit better. But if I have the same strain that's harvested just at the right time, it'll be a little more darker yellow, a tiny bit. And I'm not saying dark yellow; I'm just saying a very translucent, very appealing to the eye yellow. But it won't have that same problem that it will have with a temple ball. That's why Frenchie was always so adamant on harvesting it at the right time. And that 3-day window, he would always talk about, you have 3-day window to where it's the perfect time to harvest the resin. And temple balls are so delicate that if you could hit that 3-day window, all my temple balls that I make, all my 5 washes or 7 washes or 10 washes will all be very elastic and have that suppleness to them right when I make them and age. And you can tell they'll be secreting that oil like that one that Rick just showed us in the cellophane, like plastic. You can see it just shooting off in there. And that will be happening only with the ripeness happening. It's a direct correlation.
And so when you're dealing with material that's been taken too long and you're not finding that chemical reaction happening, do you have a theory on what is absent from that gland that has been ran too long outside that window that it doesn't?
I call it the life. I don't know what it is, but it's the life of it. It's gone.
Yeah.
It's lost its life. And there's many ways I feel like it could be sucked out. There, oxygen is a way to lose it. Heat is a way to lose it. Time is a way to lose it. And so my biggest factors I see is heat and then of course oxygen would be second in my mind, but heat will break that down really fast. And so like when it happens, when it's been overly mature, you'll see that as well. When you have an overly mature trichome, it'll have the same problem as an under mature trichome where like it won't have the elasticity when you make the temple ball. It won't want to stick together and roll into a temple ball. It want to like crumble into dust. And it's very easy to be able to tell when the plant's been harvested right when you make resin and into temple balls. And that's why I feel like there's an important connection that we need to have with the farmer, because there's something I can tell you that you can't tell yourself that easy. farming. You might be able to know when your plant's done and everything, but there's a little bit of a connection I can give you to tell you, hey, you're really hitting it when we harvest, like right here, you're really getting on point, or you harvesting a couple days early, or you've harvested a couple days late. And it's really hard for him to get, or her to get, that evidence given to them that it's that concrete. And I can give you pretty concrete evidence on it. And I've been pretty fortunate to where my farmer, who's my father-in-law, he does that just right. He's got like that window down, and there's so many factors that he looks at, and he does look at trichomes. And I've talked about this before with him, but like I said, is with he's using so much in his brain of knowledge he's packed in from 30 years of growing, that trichomes can help him understand, because he knows that genetic and that strain and how it does and how it's done when it's dry, and he knows what his buds should look like when they're done. And so there's so much going on. That's why Frenchie would always say the farmer is the key part to this, and finding a good farmer that knows all this. This is something I can't just tell you how to do or what to do or any of that. It's the farmer needs to know. He's one with his plant. He looks at it every day. He knows how to do this, and it takes just experience.
Absolutely, man. Rosenbell, you unmuted your mic a couple times. Do you want to jump in?
Yeah, I wanted to agree on that. There is that window important, and if you can tell them it comes to traditional quiche because it will, like he said, it either make it or it will butter instead of dissolve. So I agree with that. There's a window where it's very important to keep an eye on those decisions, and when in harvest, or you kind of miss the life of the hash.
Absolutely. I want to ask RJ and then Wax Plug. You're dealing with all different types of materials. Are you seeing correlations between older material and older resin and it coming through a certain way compared to resin in that sweet spot? You're muted, but you don't show as muted.
You're muted, then unmuted.
No, I'm going to switch it over to Wax Plug. RJ's going to jump out and jump back in. But yeah, same question to you, Wax Plug.
So the older stuff, I mean, it always comes with more pigment for sure. Well, can you help me understand like more what is it that you're?
So my question is that Bird is correlating when he's looking at material and recognizing it to be through his experience, eyes of experience, either premature, right in that sweet spot, or mature. He's recognizing correlations between the outcomes of his products. And I wanted to know if you were doing the same.
Yeah, we do the same thing. So we look at the biomass and we kind of look like, does it look like old, degraded? Does it look secured? And then we have the fresh frozen, and then we look at the leaf structure. So is it like a big fan leaf? That's gonna tell us there's more fat to it. If it's the dark green or the lighter greens, that kind of tells us. Am I still here? A call come in. Can you guys hear me? Cool. Well, can't hear you guys no more. But like I was saying, that looking at the biomass, we can tell from that, like, okay, what adsorbents am I going to use? And just from like Bird was saying, from doing this so many times, I kind of start tying in all these little things together, and that's how I kind of go off the knowledge. So the UV lighting will kind of be correlated to the biomass quality. So like the older biomass tends to have more of the color bands as opposed to the fresher stuff. It has less pigments in it. So it goes to that, like it's the fruit, so it's how ripe is it, how mature is it, so if it's already developed these or if it hasn't. And that's just kind of how we go based off of our extractions. It's just, based off the biomass, we kind of get an idea of where to start.
So when you were saying the older stuff, did you mean like the harvest date was a lot, like it's been sitting on a shelf for a while, or are we talking about the ripeness of when it was harvested?
So like the first thing I'll do is like I'll grab a little bunch and squish it, and if it's crispy, I know it's dry. It's been stored somewhere hot, so it's probably been decarved a lot. The second thing is I'll get a whiff of it, and then that kind of tells me if there's good terpenes in there. It's good product. I know I can refine it and get it pretty good. But if it smells rancid already, there's too many like pro-oxidants in there already. So that's where I'll do extra steps to remove, say, that oxidizing layer to slow down that whole oxidation rate and stabilize the overall product more. And then the third thing is just visually, so like if you can see the browns and the carotenoids already starting to show, if the chlorophyll has already been degraded. So based off those three things, I can kind of get an idea already, like, okay, this is where I'm gonna start. And then the amount of trichomes too, if it's like really just fan leaf and stems, or is it like really spongy, like oily biomass?
RJ, what's your experience?
Can you hear me now?
Yeah.
Okay. So we typically see a different array of materials, some very fresh, and then some very old. Maybe not very old, but on the definite older side, so definite deep in the color band. So we have a lot of reds, lots of the deep ambers, you know what I mean, borderline browns. And there's just a lot of that to wade through, I'll say, very thick in those compounds with the older the material gets. So I'd have to do a lot of remediation kind of in that sense and pulling those colors back to create still, a nice golden, beautiful hue. I'm not trying to take that out, but I'm trying to, again, like take out that kind of deep oxidized layer to pull the actual flavor or whatever's left of it forward to make it palatable.
Absolutely. Kind of wanted to ask you the same question. Are you looking at the abscission neck of the gland, and do you think that has as much bearing on a solvent-based extraction, or do you think that it's a little more forgiving in the way that you're creating material or producing material?
Yeah, I think it was interesting. I mean, Bird, I think, said it. It's a secondary plant metabolite, right? The plant's trying to produce seeds and pollen, right? That's what it's trying to do. And then it's not trying to grow trichromes to maximum development. It's doing whatever that metabolic pathway is, and it's to our benefit, and that's great. But the plant is trying to produce seeds and pollen. So I think even if it were trying to produce trichrome heads, right? Like a tomato doesn't ripen all its tomatoes at once, right? So I think, we are dealing with this. There's no probably ideal precise time, and that probably changes a little bit. And I think even perhaps stresses in the grow can cause some of these, whether it's darkening of this disc, which I would agree with all those points made about that the ambering is likely the refraction of just the darkening, the death of those cells, as it were. And I would say specifically even more so with hash making, like water hash or sifting, that you need that to break off. Whether that attachment is waterproof or not, I would say that it's probably not. It was passing oil and different metabolic secretions through it and whatnot. So whether it is or isn't, I don't know, but my intuition tells me is that it might not be. But okay, so in terms of our harvest, I kind of think about it different. I think about it teaming up with Rick. I look at it going, okay, I harvested this light, this one plant, this 4 plants, this 400 plants, whatever we're talking about. And when we harvested it at such and such a condition, I got XYZ grams per pound of oil. That oil contained what makeup of terpenes and cannabinoids. And so I would define it as, when do I have that optimal ratio that I'm looking for, and when do I have the most of it? And other than that, I wouldn't really care, no, about that obsession or the color or whatever. It would strictly come down to when those data points were met. So that would change, yeah, by different strains, by different cultivation methods. And that's kind of the beauty of doing this style of extraction, is we're not as handcuffed to that relationship with that abstention, and then that ability for it to break off and the stalks to not break off, right? And for those stalks to be of a different diameter than the head, so that we can able to filter them out, using screens or whatever. So, I mean, yeah, I think we're talking about resin, and that relationship of somebody mentioned it earlier, call it 10% amber. I kind of literally referenced that same number a few weeks ago in a discussion where I said, look, for me, it's generally around 10% amber and around 80% nice and milky, and maybe 10% of those are still nice and clear, but yeah, I think we need to keep in mind that the plant is not ripening those for the point of some harvest. It's trying to grow seeds and pollen.
Absolutely, man. Absolutely. Chevy, you've spent, some intimate time harvesting plants and doing some really cool live processing. I'd love to get your input on all this and what your opinion is.
Oh, I kind of got sidetracked with the many topics that we've been going. If you can give me a direct question.
No worries. So when we're looking at the resin and the overall plant, what are you assessing to determine viability and readiness to harvest? Are you looking for amber, or are you looking for a pinched abscission to become clear on the gland? Or is there something else in the plant that's telling you it's ready?
So originally I would use a loop and try to see the ratios of colors per resin head, but I found out the better tech was to connect more with the grower, and my indication would be basically how would the grower describe his flower when he smokes it as flower. um, I don't have that much of a palate for flower, and I have not spent enough time to assess quality that way. One of the best way just to assess what kind of hash am I going to end up with would come from smoking the flower, and usually the grower would be my answer to that. And that wouldn't happen from the get-go. It would require at least a year of a constant relationship of me sieving, introducing the hash to the grower, comparing it to the flower, and from there is where we usually assess the timing. Most of the growers that have the same strains over and over again. It's an unconventional method, but I put a lot of trust on the grower to determine. I give him few inputs and we work it that way.
Right on. That's awesome. Tom, is that something that you're utilizing, or is that something that's newer to you when Adam introduced that thought process?
Yeah, it was newer for me learning about the abscission and everything. It's definitely something I take into account and something I'm looking at.
Awesome, man. Well, I mean, I think that kind of wraps it up, guys. I really appreciate everyone's taking the time out of their day to kind of come on and talk about color, and I just want to open it up to everybody and anybody in the comments. We've got a lot of people in the room, and maybe they've got a bit more time. So if there's any comments, we welcome them, or questions. I haven't even looked at the comments myself, but
yeah, I just want to say thanks to everyone for taking the time. This has been something we kind of put together and been wanting to put together for a little bit, and really means a lot for you guys to come and join the discussion. And I think we covered a lot of ground and had a great chat. So really appreciate everyone, and thanks everyone for tuning in and joining us, because it doesn't happen without you guys. So appreciate everyone.
Yeah, man. Thanks everybody. Thanks for taking the time. We're going to wrap it up now, and we'll definitely, love to have you all back for another one of these. I think it was constructive, and we got some stuff cleared up, and I know I learned some stuff. So I appreciate everybody's taking the time, and until next time, thanks so much, and don't forget to smash that like button.
Thanks a lot for having us.
Thank you, guys.
Thank you.
Yeah, thanks for having us.